Hello there, and welcome to this quiet corner of the night, where questions drift like gentle currents through deep water. Tonight we lean into a question that has no easy answers, but one that lingers quietly in the spaces between what we know and what we wonder. What if aliens discovered Earth first? What if intelligence, consciousness, technology arrived on this blue marble not in our recent centuries of radio waves and rocket ships, but in the deep past, when the world was young and entirely different from the planet we know today? Wherever you are, whether in daylight or darkness, in the soft hours before sleep or the contemplative moments of dawn, I hope you are comfortable, settled into whatever space holds you now, ready to drift through time itself, back through the vast corridors of Earth's history. If you find yourself drawn to these explorations of deep time and cosmic possibility, you might consider joining others who wonder about such things. Perhaps subscribe to continue these journeys together into the unknown. Now, let's begin this gentle voyage backward, through layers of time so deep that our entire human story becomes just the thinnest film on the surface of a much larger mystery. The Earth beneath our feet has been turning for 4.5 billion years. 4.5 billion. The number itself seems to dissolve meaning, becoming more poetry than mathematics, more feeling than fact. In all those eons of rotation, of seasons that came and went without names, of continents that drifted like sleeping, giants across the face of the planet, intelligence as we understand it, the kind that builds cities and writes songs and looks up at stars with longing, has existed for perhaps 50,000 years. Maybe 100,000, if we stretch our definition to include the earliest stirrings of symbolic thought, the first cave paintings that whispered across time. We were here, we saw beauty, we tried to capture it. But what about all those years before? What about the millions of centuries when this planet spun in space, its oceans deep and mysterious, its land masses arranged in configurations we can barely imagine? The Silurian period alone, that ancient chapter of Earth's story from which geologist Gavin Schmidt borrowed a name for his famous thought experiment, lasted for 24 million years. 24 million years of forests and seas, of creatures we've never met, of weather patterns and seasonal cycles and daily sunrises over landscapes that would seem alien to our eyes. In those vast stretches of time, in those deep chapters of planetary history that existed long before the first human ever wondered about the stars, could intelligence have arrived from somewhere else? Could visitors from distant worlds have found our planet in its youth, walked its shores, swum in its seas, left traces of their presence in ways we're only now beginning to imagine? Tonight, we follow this possibility not toward any definitive answer, but into the gentle mystery of deep time itself, where questions multiply like stars and wonder becomes a form of archaeology. The invitation is simple: to let go of our assumed place at the center of Earth's story, and to consider the possibility that consciousness, curiosity, technology, all the things we think of as uniquely and recently human, might have touched this world in chapters of its story that we've barely learned to read. Deep time stretches behind us like an ocean whose far shore vanishes beyond the horizon of imagination. 4 billion years. The phrase rolls through the mind like waves, each repetition making the vastness feel both more real and more impossible to grasp. If we could compress all of Earth's history into a single year, human civilization would occupy only the final few seconds before midnight on December 31st. Our entire recorded history, all the empires and discoveries, all the art and architecture, all the moments we think of as permanent fixtures in the story of this world, would flash by faster than a heartbeat in that cosmic calendar. But what fills all those months and seasons that came before? What happened in Earth's January, its March, its long summer months when no human eyes witnessed the turning of days into nights? The planet was not empty. It was not waiting. Life flourished and evolved, Landscapes shifted like slow dreams, and the dance between ocean and atmosphere and stone created endless variations on themes we're still learning to recognize. And in all that time, across all those eons when Earth spun in the darkness of space, aware and alive but not yet conscious in the way we understand consciousness, what else might have been happening? The rock record speaks, but in a language so subtle, so easily erased by time, that we catch only fragments of conversations that stretched across millions of years. Fossils preserve the shapes of ancient creatures, but they preserve almost nothing of behavior, nothing of intelligence, nothing of the kind of sophisticated awareness that might build tools or structures or machines. The geological record is biased toward the big and the durable, toward bones and shells and the slow accumulation of sediment. It does not easily hold on to evidence of visitors, especially visitors who might have been careful, who might have respected the integrity of the worlds they explored. You consider what would remain of our own civilization if it vanished tomorrow, and time was given millions of years to work its patient erasure. The cities we think of as permanent would crumble within centuries. Steel would rust, concrete would crack and be claimed by vegetation, plastic would break down under ultraviolet light and the persistent chemistry of weather. Even our most ambitious monuments, even the pyramids and stone circles we imagine as eternal, would eventually be worn smooth by wind and rain, buried under layers of sediment, forgotten by the very continents on which they stand. After 1,000,000 years, almost nothing recognizably human would remain on the surface of the earth. After 10 million years, even the deepest archaeological layers would be compressed, heated, chemically altered by the slow processes of geology. The evidence of our entire technological civilization might be reduced to a thin, anomalous layer in some future rock formation, a brief spike in unusual isotopes, perhaps, or a scatter of synthetic compounds that would puzzle some unimaginably distant archaeologist. This is the challenge of deep time, the reason why the question of ancient visitation becomes so intriguingly possible. The Earth is not a museum. It does not preserve everything. It is a living, changing system that constantly recycles its materials, constantly writes new stories over old ones, constantly transforms the evidence of the past into the raw materials of the future. What we see when we look at the geological record is not a complete history of everything that ever happened on this planet. It is a highly selective archive, biased toward certain kinds of events and certain kinds of materials, edited by 4 billion years of erosion and burial and chemical transformation. In this context, absence of evidence begins to feel less like evidence of absence and more like an invitation to wonder. What might have visited Earth in its deep past that left no trace we would recognize? What kind of intelligence might have walked these ancient shores, swum in these prehistoric seas, observed the slow dance of evolution and continental drift, without leaving behind the kind of monuments and artifacts that would survive the patient? Work of geological time? The Silurian hypothesis whispers to us across the vastness of geological time, a thought experiment born from the mind of climatologist Gavin Schmidt and named for an ancient period when Earth's continents wore entirely different shapes. It poses a question so simple it seems almost childlike, yet so profound it reshapes how we think about intelligence and time. If an advanced civilization had existed on Earth millions of years ago, what evidence would we be able to find today? Schmidt and his colleagues approached this question not with certainty but with curiosity, applying the same rigorous thinking they used to study climate change to the puzzle of deep archaeological time. What they discovered was humbling. Even a civilization as technologically sophisticated as our own, one that had reshaped entire landscapes and altered the chemistry of the atmosphere, would leave traces so faint after just a few million years that they might easily be missed by future archaeologists who didn't know exactly what to look for. The hypothesis takes its name from the Silurian period, which lasted from about 443 to 419 million years ago. During this ancient chapter of Earth's story, life was still largely confined to the oceans, and the land was mostly barren except for simple plants beginning their first tentative colonization of the continents. It was a world so different from ours that it might as well have been an alien planet. Yet it lasted for 24 million years, longer than the entire history of grass on Earth, longer than the existence of most mammalian lineages, longer than the time between the extinction of the dinosaurs and the present moment. 24 million years. The phrase becomes a meditation on the true scale of geological time, on the vast chapters of Earth's history that preceded not just human civilization, but human existence, human evolution, the evolution of mammals, the first footsteps of any vertebrate on dry land. In such stretches of time, entire landscapes could rise and fall, entire ecosystems could evolve and flourish and vanish, entire climatic cycles could run their course dozens or hundreds of times over. And if, in such a span of time, intelligence had emerged, not from the slow evolution of terrestrial life, but from the stars themselves, what traces would remain? The mathematics of preservation work against us here. The older a potential archaeological site becomes, the more likely it is to be destroyed by the processes that constantly reshape the Earth's surface. Erosion wears down mountains. Plate tectonics carries continents across the globe, subducting some portions of the seafloor back into the molten interior while creating new ocean floor elsewhere. Glaciers advance and retreat, scraping away entire landscapes and depositing their remains in new configurations hundreds of miles from their origins. Even the most durable materials break down eventually. Bronze corrodes, stone cracks and crumbles. Even the hardest ceramics and glasses become brittle with age and thermal cycling. The synthetic materials we think of as permanent, plastics, composites, engineered alloys, have not existed long. Enough for us to know how they behave across geological time scales, but the chemistry suggests that they too would eventually surrender to the patient work of oxidation and hydrolysis and photodegradation. What survives, then, across such vast periods? Primarily changes to the planet itself, alterations in the chemistry of ancient atmospheres, shifts in the isotopic composition of sedimentary layers, patterns of extinction and radiation in the fossil record that might reflect something other than natural climate cycles or asteroid impacts. These are subtle traces, requiring sophisticated analysis to detect and even more sophisticated interpretation to understand. The Silurian hypothesis suggests that we might be looking for the wrong kind of evidence entirely. Instead of searching for artifacts and ruins, perhaps we should be looking for anomalies in the deep record of Earth's climate and chemistry. Instead of expecting to find alien cities preserved in stone, perhaps we should be scanning sediment cores for isotopic signatures that don't quite match what we would expect from purely natural processes. This shift in perspective opens up new possibilities and new questions. What if evidence of ancient visitation exists not in the form of monuments or machines, but in the form of chemical fingerprints left behind in the very rocks and ice and sediments that form the Earth's memory of its own past? Stone holds memory, but it holds it in ways that time transforms beyond easy recognition. The most durable materials known to humanity, granite monuments, ceramic vessels, bronze tools, these testaments to permanence dissolve into whispers when measured against the patient persistence of geological processes. What we think of as eternal becomes temporary when the scale extends beyond human lifespans, beyond the existence of entire species, into the deep archives of planetary time. Consider the oldest human artifacts we have discovered. Stone tools, from Ethiopia, perhaps 3.5 million years old. Cave paintings in Spain and France, some reaching back 65,000 years. These feel ancient to us, impossibly old, yet they represent the merest surface scratches on the timeline of Earth's existence. They survived not because stone and pigment are truly permanent, but because the conditions were exactly right. Dry. Caves, stable temperatures, protection from the chemical processes that normally break down even the hardest materials. But these preservational sweet spots are rare. Most of the Earth's surface experiences constant change. Water seeps into cracks and freezes, expanding with enough force to split solid rock. Acids produced by living organisms and atmospheric chemistry eat slowly through limestone and marble. Temperature changes cause expansion and contraction that gradually loosens the bonds between mineral grains. Even in the absence of dramatic geological events, the simple passage of time is enough to reduce mountains to sand, to transform entire landscapes into sedimentary layers that tell only the most general story of what once existed there. Metal, that cornerstone of technological civilization, fares even worse. Iron oxidizes into rust that crumbles at a touch. Copper develops patina that protects it temporarily but eventually succumbs to deeper corrosion. Even gold, the most chemically stable of metals, can be dissolved by certain combinations of acids and salts given enough time. The Bronze and Iron Ages of human history would leave almost no direct evidence after even a few 100,000 years, let alone the millions of years we're considering when we think about deep time visitation. The synthetic materials that define our modern technological age are even more ephemeral. Plastics break down under ultraviolet radiation, their long molecular chains fragmenting into smaller and smaller pieces until they become indistinguishable from other organic compounds in the environment. Composites separate as their binding agents fail. Semiconductors, those marvels of precision engineering that make possible our computers and communication devices, are so delicate that they require constant environmental control even during their brief functional lifespans. What, then, might survive from a hypothetical ancient technological civilization? Perhaps only the most indirect traces. Changes in isotopic ratios that reflect unusual concentrations of rare elements. Patterns in sedimentary layers that suggest mining or excavation on a large scale. Anomalous carbon signatures that might indicate extensive burning of fossil fuels or biomass. Chemical compounds that don't occur naturally and require sophisticated processing to create. Even these traces would be subtle, easily missed by researchers, who weren't specifically looking for them, easily explained by natural processes if considered in isolation. The search for evidence of ancient visitation becomes, in this context, less like traditional archaeology and more like forensic science applied to the deep past. It requires not the discovery of obvious artifacts, but the detection of subtle anomalies and patterns that we're only beginning to learn how to read. This erasure by time applies not only to physical artifacts but to the landscapes themselves. The Earth of even a few million years ago was geographically unrecognizable. Coastlines occupied different positions. Mountain ranges had different elevations. River systems followed different paths. Climate zones existed in different locations. Any visitors to ancient Earth would have encountered a world whose very geography has since been altered beyond recognition by the slow but relentless processes of continental drift and erosion. In this context, the absence of obvious evidence for ancient technological activity becomes less surprising and more inevitable. The Earth is not a museum that preserves everything that has ever existed on its surface. It is a dynamic system that constantly recycles its materials, constantly writes new stories over the traces of old ones. The question becomes not why we haven't found clear evidence of ancient visitation, but whether such evidence could possibly survive the deep erosive work of geological time, and whether we would recognize it if it did. Before the Cambrian explosion painted the oceans with the first complex ecosystems we might recognize, before the first vertebrate ever dreamed of leaving the water for land, Earth spun through space. For billions of years in configurations of continents and climates that would seem alien to our eyes. These deep chapters of planetary history stretch back through timescales that dwarf not just human civilization, but the entire evolutionary story of complex life itself. In these ancient eons, when the very atmosphere held different proportions of gases, when the sun burned with different intensity, when the moon hung closer to Earth and the days were shorter, what possibilities existed that we can barely imagine from our vantage point in the present? The Precambrian Superion encompasses nearly 90% of Earth's entire history, a vast expanse of time during which our planet transformed from a molten ball of rock into a complex system capable of supporting life, yet still innocent of the intricate ecosystems that would eventually evolve into forests and coral reefs and all the biological complexity we now take for granted. For most of this immense period, life consisted primarily of single-celled organisms, bacteria, and archaea that slowly transformed the atmosphere by learning to harness the energy of sunlight through photosynthesis. But photosynthesis itself represents a technological breakthrough of staggering sophistication. The molecular machinery required to capture photons and convert their energy into chemical bonds involves quantum mechanical processes so subtle and precise that human scientists are still working to fully understand them. If such complexity could emerge through natural selection over millions of years, what other forms of complexity might have been possible during the deep time that preceded complex multicellular life? Here, the imagination finds itself in strange territory, contemplating possibilities that stretch the boundaries of what we normally consider when we think about life and intelligence. During the Archean Eon, which lasted from about 4 billion to 2.5 billion years ago, Earth's surface was hot and volcanic, its atmosphere thick with methane and ammonia and carbon dioxide. Yet, even in this apparently hostile environment, life not only existed, but thrived, developing metabolisms based on chemical reactions that would be toxic to most modern organisms. Could intelligence from elsewhere in the universe have found such a world not hostile, but merely different? A planet with its own unique chemistry and energy sources that might support forms of life and technology based on entirely different principles than those familiar to us. The question opens doorways to possibilities so strange they resist easy categorization. What if the visitors to ancient Earth were themselves products of worlds where life had taken paths so different from our own evolutionary history that their technology, their very presence, would be as invisible to our current understanding as quantum mechanics would be invisible to a medieval scholar? The deep oceans of Precambrian Earth might have been particularly hospitable to visitors from water worlds. Without the complex marine ecosystems that now populate our seas, those ancient oceans would have been vast expanses of relatively simple chemistry, rich in dissolved minerals, perhaps perfect for beings whose evolution had occurred in similar, aquatic environments elsewhere in the galaxy. The water itself would have provided protection from radiation, temperature stability, and chemical resources in forms that might be immediately usable by technologies we cannot easily imagine. Even the apparent simplicity of Precambrian life might have been an advantage from the perspective of visiting intelligences. Complex ecosystems are delicate, easily disrupted by the introduction of new elements or the alteration of environmental conditions. But the microbial communities that dominated early Earth were robust, adaptable, capable of surviving and even thriving in conditions that would devastate more specialized organisms. Visitors who wished to study planetary systems without disrupting them might have found Precambrian Earth an ideal laboratory, a world where their presence could be sustained without causing the kind of ecological catastrophe that might result from contact with more complex ecosystems. The question of evidence becomes even more intriguing when considered in this context. The geological record from the Precambrian is sparse and heavily altered by billions of years of subsequent geological activity. Most of the rocks from this period have been metamorphosed multiple times, their original chemistry and structure transformed by heat and pressure into forms that preserve only the most general characteristics of their origins. Yet, even in these ancient, altered rocks, scientists have found evidence of the earliest life on Earth, preserved in the form of chemical signatures and microscopic structures that speak to the existence of thriving microbial communities billions of years in the past. If such subtle traces of primitive life can survive such vast spans of time and geological transformation, what other signatures might be waiting to be discovered by researchers who know how to look for them? Perhaps they arrived not as conquerors, seeking to claim new territory, but as wanderers drawn by curiosity, as patient observers content to study and understand rather than to alter or possess. This possibility transforms the entire question of ancient visitation from one of invasion or colonization to one of gentle scholarship, of beings whose approach to new worlds might have been guided by principles of non-interference, of respect for the natural processes they encountered. The universe is vast and ancient, filled with billions of galaxies, each containing billions of stars, many surrounded by planets where conditions might allow the development of life and consciousness. In such a cosmos, intelligence might be not rare but common, arising whenever and wherever conditions permit, creating a galaxy populated by countless forms of awareness, each shaped by the unique evolutionary history of its home world. If this is so, then perhaps the cosmos has developed something like protocols for contact, unwritten rules that emerge naturally when civilizations mature enough to travel between the stars. What might such protocols look like? Perhaps they would emphasize observation over intervention, understanding over exploitation. Perhaps they would recognize that each world represents a unique experiment in the development of life and consciousness, deserving of respect and protection rather than alteration or control. Perhaps they would be guided by a kind of cosmic ethics that values diversity and natural development over the imposition of external values or technologies. From this perspective, ancient visitors to Earth might have been something like cosmic naturalists, beings whose primary interest lay in documenting and understanding the processes by which life emerges and evolves on different worlds under different conditions. They might have established research stations in locations carefully chosen to minimize their impact on natural systems. Deep ocean trenches, polar regions, underground caverns, orbital platforms that left no trace on the planetary surface. Such visitors might have been particularly drawn to Earth during periods of major evolutionary transition, moments when life was developing new capabilities or exploring new ecological niches. The emergence of photosynthesis, the development of complex multicellular organisms, the first colonization of terrestrial environments, these would have been fascinating processes to observe and document, natural experiments of cosmic significance, unfolding over timescales that even long-lived civilizations might measure in generations. The Great Oxidation Event, which occurred roughly 2.5 billion years ago when photosynthetic organisms began producing oxygen in quantities large enough to fundamentally alter Earth's atmospheric chemistry, would have been particularly significant to any observers interested in planetary evolution. This was a transformation that changed not just the chemistry of the atmosphere, but the entire trajectory of life on Earth, making possible the evolution of oxygen-breathing organisms and ultimately leading to the complex ecosystems we know today. From an observational standpoint, such an event would have been unprecedented in its significance, a planetary-scale transformation that might occur only once in the history of any given world. Beings capable of interstellar travel might have traveled vast distances to witness and document such a transition, establishing long-term monitoring stations that could track the process over the millions of years required for its completion. The evidence for such presence would necessarily be subtle, designed not to interfere with the natural processes being observed. Perhaps it would consist of anomalous isotopic signatures in deep ocean sediments, traces of materials that don't occur naturally on Earth, but might be common on other worlds. Perhaps it would take the form of microscopic structures buried in ancient rock formations, so small and so carefully integrated into natural geological processes that they would be indistinguishable from ordinary mineral formations except under the most sophisticated analysis. Such visitors might also have been drawn to Earth's unique position in what astronomers call the Goldilocks zone, the narrow band around each star where liquid water can exist on planetary surfaces. Earth has remained in this zone for billions of years, despite the gradual increase in solar luminosity that has occurred as our sun ages. This stability has allowed life not just to emerge but to persist and diversify over geological time scales, creating the kind of long-term evolutionary laboratory that might be rare in the cosmos. The patience required for such observation would be extraordinary by human standards. To properly document the evolution of complex life on a world like Earth would require not decades or centuries of observation, but millions or tens of millions of years. Only beings with lifespans measured in geological time, or civilizations, stable enough to maintain institutional continuity across such vast periods, could undertake such projects. Yet perhaps such patience is natural to intelligence that has learned to think in cosmic terms, to species that have transcended the brief lifespans and urgent concerns that dominate the thinking of young civilizations like our own. Beneath miles of water, in the deepest trenches and abyssal plains where sunlight has never penetrated, the ocean holds its most ancient secrets in chambers of eternal darkness. These depths remain largely unexplored even by our most sophisticated modern technology, vast, three-dimensional spaces where the pressure crushes most materials we consider durable, where temperatures hover just above freezing, where time moves differently in the absence of seasonal cycles or daily rhythms. The deep ocean is Earth's most stable environment, largely unchanged over millions of years while continents drift and climates shift and ice ages come and go across the surface world. In the deepest parts of the Pacific, sediments accumulate grain by grain at rates so slow that a single layer might represent thousands of years of deposition. These are archives of unimaginable patience, repositories of information that extend back through geological time with a completeness and fidelity that no surface environment can match. Here, in these alien depths, conditions exist that might have been particularly suitable for visitors from worlds where life evolved under high pressure and low temperatures. The chemistry of the deep ocean is rich and complex, with dissolved minerals and trace elements that create a kind of primordial soup, not unlike the conditions that may have existed on early Earth when life first emerged. For beings whose evolution occurred in similar aquatic environments elsewhere in the cosmos, such depths might have seemed not hostile but familiar, perhaps even welcoming. The Mariana Trench, deepest of Earth's ocean trenches, plunges nearly 7 miles below sea level into regions of crushing pressure and perpetual darkness. Yet even at these extreme depths, life flourishes in forms so alien to surface-dwelling organisms that they seem to belong to a different planet entirely. Creatures exist here that derive their energy not from sunlight, but from the chemical gradients created by volcanic vents, beings that have evolved under conditions so different from surface life that they represent entirely separate evolutionary experiments in the possibilities of consciousness and complexity. If life from Earth can adapt to such extreme conditions, what forms of intelligence from other worlds might find such environments not just tolerable, but optimal? The deep ocean trenches of ancient Earth would have provided perfect refuge for visitors who preferred to observe without being observed, to study planetary processes from locations so remote and inaccessible that their presence would remain undetected by any surface-dwelling life forms that might eventually evolve. The thermal vents that dot the deep ocean floor create oases of chemical energy in the otherwise nutrient-poor abyssal depths. These natural reactors, powered by the heat of the Earth's interior, create complex chemistry that supports entire ecosystems independent of solar energy. They represent a kind of alternative biosphere, one that might serve as a model for life on worlds orbiting distant stars, where the energy for biological processes comes not from stellar radiation, but from planetary geothermal activity. Ancient visitors might have been particularly drawn to these vents, seeing in them chemical processes, similar to those that powered life on their own home worlds. They might have established research stations near these natural laboratories, using the energy and raw materials provided by the vents to power technologies based on principles entirely different from anything developed by surface-dwelling civilizations. The key evidence for such presence would be subtle beyond our current ability to detect. Deep ocean sediments preserve chemical records with extraordinary fidelity, but the vast majority of the deep ocean floor remains unmapped and unsampled. We have more detailed knowledge of the surface of Mars than we do of our own ocean depths. The technology required to explore these regions thoroughly, to sample and analyze the sediment layers that might contain evidence of ancient activity, is only now being developed. Even if such evidence exists, it would require sophisticated analysis to distinguish artificial signatures from natural processes. The deep ocean is a realm of complex chemistry, where unusual isotopic ratios and trace element concentrations might result from natural geological processes rather than technological activity. The challenge becomes one of pattern recognition, of identifying signatures that are too regular, too organized, too unlikely to result from purely natural processes. Perhaps the most intriguing possibility is that deep ocean installations might still be active, powered by geothermal energy and designed to operate autonomously for geological time periods. Such systems might be so well integrated into natural deep ocean processes that they would be indistinguishable from biological or geological phenomena except under the most careful examination. They might function as monitoring stations, collecting data about planetary processes and transmitting it through means we don't yet understand to recipients whose location we can't yet imagine. The deep ocean keeps its secrets well, protected by distance and pressure and the simple fact that so few explorers have ever ventured into its deepest regions. Layers of rock hold stories we're only beginning to read, each stratum a page in Earth's autobiography written in the language of minerals and chemistry, pressure and time. The geological record extends back billions of years, a library of stone that preserves evidence not just of life and climate, but of every process that has shaped the planet's surface and interior. Yet, for all our advances in geological science, for all our sophisticated tools of analysis and dating, we have barely begun to decode the full complexity of information stored in these ancient archives. Each layer of sedimentary rock represents a moment in Earth's history, a slice of time when particular conditions existed, when certain chemical processes were active, when specific environments covered the regions where those sediments were deposited. The thickness of layers tells us about the rate of deposition. The grain size speaks to the energy of ancient currents and winds. The mineral composition reveals the chemistry of ancient atmospheres and oceans. The isotopic ratios provide clues to temperature and biological activity and the cycling of elements through the Earth system. But reading these records requires more than just technical knowledge. It requires a kind of temporal imagination, the ability to envision landscapes and climates and ecosystems so different from our present world that they might as well belong to alien planets. The Earth of the Devonian period, when forests first began to colonize the continents, was a world where no grass existed, where no flowers bloomed, where the largest land animals were primitive arthropods the size of small cars. The Earth of the Permian period, just before the greatest mass extinction in the planet's history, was dominated by reptiles and amphibians living under skies that held different concentrations of oxygen and carbon dioxide than anything humans have ever breathed. In these ancient worlds, recorded in layers of limestone and sandstone and shale that we can touch and sample and analyze, what other stories might be preserved alongside the obvious narratives of biological and climatic change? If visitors from other worlds had indeed walked these ancient landscapes, swum in these prehistoric seas, observed these long-vanished ecosystems, what traces might they have left in the geological record? The question becomes one of recognizing anomalies, of identifying patterns in the rock record that don't quite fit our understanding of purely natural processes. Unusual concentrations of rare elements that might indicate mining or industrial activity. Isotopic signatures that suggest artificial nuclear processes. Chemical compounds that require high temperatures or exotic chemistry to produce. Patterns of erosion or deposition that seem too organized, too purposeful to result from random geological processes. Some researchers have pointed to puzzling features in ancient rock formations that resist easy explanation. Layers with unusual mineral compositions that don't match what we would expect from known geological processes. Structures in ancient rocks that resemble artificial constructions but are found in formations millions of years older than any known life complex enough to build such things. Anomalous isotopic ratios that suggest nuclear processes occurring under conditions where such processes shouldn't be possible naturally. These anomalies are typically explained as the result of poorly understood geological processes. Unusual. But natural conditions that occurred during the formation of these ancient rocks. And in most cases, such explanations are probably correct. The Earth's geological history includes events and processes so extreme, so different from anything we can observe directly, that they stretch the boundaries of our understanding. Massive volcanic eruptions that covered entire continents with lava. Asteroid impacts that temporarily turned the atmosphere into plasma. Episodes of rapid climate change that transformed ice ages into greenhouse conditions within centuries or decades. Yet, the possibility remains that some of these anomalies might represent something else entirely, traces of activity that occurred outside the framework of purely terrestrial processes. The challenge lies in developing criteria for distinguishing between the signatures of exotic but natural geological events and evidence of technological activity by intelligence from elsewhere. This search requires not just new analytical techniques, but new ways of thinking about the relationship between life, intelligence, and planetary processes. If visitors to ancient Earth had indeed possessed technologies based on principles we don't yet understand, operating on energy sources we haven't yet learned to harness, using materials with properties we haven't yet discovered, then the signatures they left behind might not resemble anything we would expect to find. The rock record preserves not just the obvious stories of volcanic eruptions and climate change and biological evolution. It also holds subtler narratives, chemical signatures and isotopic patterns and mineral assemblages that speak to processes we're still learning to recognize. In this vast library of stone, written over billions of years in languages we're only beginning to translate, what other stories might be waiting to be discovered by readers who know how to look for them? Isotopic echoes of visitation might rest in the chemical fingerprints left behind in ancient sediment, signatures so subtle that they require the most sophisticated analytical techniques to detect, yet potentially so distinctive that they could provide unambiguous evidence of technological activity occurring millions of years before complex life evolved on Earth. The study of isotopes, variants of chemical elements that differ in atomic mass but share the same chemical properties, has become one of the most powerful tools for understanding processes that occurred in the deep past, revealing stories that would otherwise remain forever hidden in the geological record. Natural processes create isotopic signatures that follow predictable patterns, ratios that reflect the physics of radioactive decay, the thermodynamics of chemical reactions, the biology of metabolic processes. When organisms incorporate carbon from atmospheric carbon dioxide into their tissues, They preferentially select the lighter isotope, carbon-12, over the heavier carbon-13, creating a distinctive signature that paleontologists use to identify biological activity in ancient rocks. When uranium decays into lead over millions of years, the ratio of different lead isotopes provides a precise chronometer that allows geologists to date the formation of rocks with extraordinary accuracy. These natural isotopic patterns form a kind of background against which anomalies become visible, deviations from expected ratios that suggest processes operating outside the normal framework of geological and biological chemistry. The key insight is that different processes, biological, geological, and potentially technological, create different isotopic signatures, fingerprints that remain detectable long after the processes themselves have ceased. Technological processes often create isotopic ratios that don't occur in nature. Nuclear reactors, for example, produce distinctive patterns of uranium and plutonium isotopes that could remain detectable in sedimentary layers for millions of years. Industrial processes that concentrate or purify specific elements might leave behind residues with isotopic compositions that differ significantly from natural ores. Even advanced materials science might involve the manipulation of isotopic ratios to create materials with specific properties, leaving behind waste products or byproducts with signatures that could persist in the geological record. The search for such signatures requires not just sophisticated analytical equipment, but also a deep understanding of what kinds of isotopic anomalies might be produced by technologies we can imagine, and, more challengingly, by technologies that operate according to principles we haven't yet discovered. This becomes a kind of forensic investigation applied to deep time, looking for evidence of activity that might have occurred under conditions and using methods that stretch the boundaries of our current scientific understanding. Some researchers have reported finding unusual isotopic signatures in very ancient rocks, patterns that don't quite match what would be expected from purely natural processes. Ratios of noble gas isotopes that suggest exposure to artificial neutron sources. Concentrations of rare earth elements that seem too high and too localized to result from normal geological processes. Patterns of isotopic fractionation that require temperatures or pressures that shouldn't have existed under the conditions present when these rocks were formed. These anomalies are typically attributed to poorly understood natural processes. Exotic geological conditions that occurred during the formation of these ancient rocks. The early Earth was a violent and dynamic place, with conditions so extreme that they produced chemical and physical processes unlike anything we can observe directly today. Massive impact events delivered energy equivalent to billions of nuclear weapons. Volcanic episodes released more material than all human industrial activity combined. Chemical reactions occurred under temperatures and pressures that we can only approximate in the most sophisticated laboratory equipment. Yet, the possibility remains that some of these isotopic anomalies might represent traces of technological activity, signatures left behind by visitors who possess the ability to manipulate matter at the atomic level, who used energy sources based on nuclear processes, who created materials with isotopic compositions that don't occur naturally on Earth. The challenge lies in developing criteria for distinguishing between the signatures of extreme but natural geological processes and evidence of artificial manipulation of isotopic ratios. This investigation requires a kind of detective work that spans multiple disciplines, combining expertise in geochemistry, nuclear physics, materials science, and astrobiology. It requires not just the ability to measure isotopic ratios with extraordinary precision, but also the theoretical framework to understand what kinds of signatures might be produced by technologies that operate according to principles we're still developing. The isotopic record extends back billions of years, preserved in rocks and minerals that have survived multiple episodes of heating, cooling, and chemical alteration. In this ancient chemical library, written in the language of atomic masses and decay rates, What stories might be waiting to be discovered by investigators who know how to read the subtle signatures of artificial processes? The mathematics of deep arrival suggests that intelligence may have emerged countless times before us, arising and flourishing and perhaps departing in cycles that span the vast stretches of cosmic time. The universe is nearly 14 billion years old, ancient beyond our ability to truly comprehend, and for most of that vast duration, the conditions necessary for the development of life and consciousness have existed in countless locations throughout the cosmos. If intelligence is not unique to Earth but rather an emergent property that appears wherever conditions allow, then the statistical probability becomes not whether other civilizations have existed, but how many have existed, and when. The Drake equation, formulated by astronomer Frank Drake in the 1960s, attempts to estimate the number of communicating civilizations currently active in our galaxy. But the equation can be modified to consider not just contemporary civilizations, but the total number of technological species that might have emerged throughout galactic history. When the timescales are extended to encompass billions of years rather than the brief span of human technological development, the numbers become staggering. Consider that our own galaxy, the Milky Way, contains hundreds of billions of stars, many of them older than our own Sun, many surrounded by planetary systems where conditions might permit the development of life. If even a tiny fraction of these systems gave rise to intelligence over the course of galactic history, the total number of technological civilizations that have existed becomes immense. Some would have emerged and vanished billions of years, before our solar system even formed. Others might have flourished during the long epochs when Earth itself existed, but was populated only by primitive microorganisms. The timescales involved dwarf human experience so completely that they become almost meaningless as numbers and transform into something more like poetry, more like meditation on the nature of time itself. A billion years ago, when the first complex multicellular organisms were just beginning to appear in Earth's oceans, entire galactic civilizations might have already risen to technological maturity, explored their local regions of space, developed technologies we can't imagine, and either transcended their physical origins or gently declined into extinction, leaving behind only the most subtle traces of their existence. From this perspective, the question becomes not whether ancient visitors might have found Earth during its long pre-human history, but rather how many different civilizations might have discovered our planet, studied its development, perhaps established research stations or observation posts to monitor the slow evolution of terrestrial life. Earth has been a potentially interesting world for billions of years, a stable planet in the habitable zone around a well-behaved star, showing clear signs of active geology and atmospheric chemistry that might indicate the presence of life. The statistical argument becomes even more compelling when we consider the possibility that spacefaring civilizations might have lifespans measured not in thousands of years, like human civilization, but in millions or billions of years. A species that achieves technological maturity and then maintains stable, long-term institutions might persist for geological time periods, watching entire planets evolve from sterile rocks to complex biospheres, observing the rise and fall of countless lesser civilizations, accumulating knowledge and wisdom across timescales that make human history appear as brief as a single day. Such ancient civilizations might develop something like a galactic perspective, an understanding of cosmic processes that encompasses not just their own local stellar neighborhood, but the evolution of entire galactic regions over billions of years. From such a perspective, individual planets like Earth might be seen not as potential colonies or resources to be exploited, but as natural experiments in the development of life and consciousness, deserving of careful study and protection rather than interference or alteration. The mathematics suggest that if intelligence is even moderately common in the universe, then Earth has almost certainly been discovered, studied, and perhaps revisited multiple times throughout its history by civilizations whose technological Capabilities might be as far beyond our own as our capabilities exceed those of the earliest bacteria. The absence of obvious evidence for such visitation becomes, in this context, less an indication that it never occurred, and more a testament to the subtlety and care with which such advanced beings might approach the study of developing worlds. This statistical framework transforms the entire question of ancient visitation from one of speculation about rare and unlikely events to one of attempting to understand how such visitation might have been conducted, what traces it might have left behind, and why those traces might be difficult for us to recognize and interpret. The numbers suggest not that we are alone, but rather that we are newcomers to a cosmos that has been populated by intelligence for billions of years before our own species learned to look up at the stars and wonder about our place in the universe. Crystalline structures, forgotten towers built from materials we don't recognize, might rest beneath miles of sediment or dissolved into the chemistry of ancient oceans, leaving behind only the most subtle signatures of their former existence. The architecture of visiting civilizations need not have resembled anything familiar to us, need not have followed the principles of construction we understand, need not have been built from stone and metal and the organic materials that define human engineering. Consider the possibility of technologies based on principles we have barely begun to explore. Crystals that grow according to programmed patterns, self-assembling structures that organize themselves from dissolved minerals according to information encoded in their molecular lattices. Materials that exist at the boundary between living and non-living, between organic chemistry and inorganic physics, capable of growth and adaptation and response to environmental conditions in ways that blur our traditional distinctions between organism and artifact. Such technologies might leave traces in the geological record that we would mistake for natural formations, mineral deposits that formed under conditions slightly different from what we would expect, crystal structures that are almost but not quite identical to those produced by purely geological processes. The subtlety of these signatures would make them nearly impossible to detect without specific knowledge of what to look for, and even then they might be easily dismissed as anomalous but natural formations. The deep caves and underground chambers that honeycomb the Earth's crust might preserve evidence of ancient construction that would be invisible from the surface. These natural caverns exist in a state of environmental stability that surface locations can never maintain, protected from weathering and temperature fluctuation and the constant recycling of materials that characterizes surface geology. Temperatures remain constant for millennia. Chemical conditions change slowly, if at all. Structures built in such environments might persist for millions of years with minimal degradation. Some of the world's deepest caves contain mineral formations of extraordinary beauty and complexity, crystalline growths that follow mathematical patterns of such precision and regularity that they seem almost artificial. Limestone caverns filled with calcite formations that spiral and branch according to principles that mathematical crystallographers are still working to understand fully. Salt caves where evaporation has created geometric patterns of almost architectural complexity. Most of these formations are assumed to be purely natural, the result of groundwater chemistry and mineral precipitation following the laws of physics and chemistry over thousands or millions of years. But the mathematics of crystal growth is subtle and complex, and small changes in initial conditions can lead to dramatically different final structures. What if some of these formations represent not pure natural process but the remnants of technologies that worked by directing and controlling natural crystal growth according to predetermined patterns? The distinction between natural and artificial might become meaningless when applied to technologies sophisticated enough to work with the fundamental processes of matter organization. A civilization capable of programming crystal growth might create structures that are simultaneously natural in the sense that they follow the laws of chemistry and physics, and artificial in the sense that their specific forms result from intentional design rather than random processes. Such technologies might have been particularly attractive to visitors whose own evolution occurred on worlds where mineral-based rather than carbon-based chemistry dominated. Silicon-based life forms, if they exist, might naturally develop technologies that manipulate crystal structures rather than organic polymers. Their cities and tools and vehicles might grow from seed crystals according to information patterns encoded in molecular templates, creating structures that would seem magical to us but would be as natural to them as wood construction is to human civilizations. The evidence for such technologies would be preserved not in the form of ruins, but in the form of mineral deposits, with properties that are almost but not quite explainable by known geological processes. Crystal formations with symmetries that are slightly too perfect, too regular, too organized to result from random nucleation and growth. Mineral assemblages that require conditions slightly different from those that existed when the rocks containing them were formed. Even more intriguingly, such crystal-based technologies might still be active, growing and changing and adapting to environmental conditions over geological time periods. What we interpret as natural cave formations might actually be slow-growing technological systems, so well integrated into geological processes that they are indistinguishable from natural mineral precipitation, except under the most sophisticated analysis. They might function as monitoring stations or communication networks or memory storage systems, operating on timescales that make human technology seem as brief and ephemeral as mayfly lives. The Fermi paradox reversed asks not where they are, but where were they, shifting our perspective from the present moment to the vast expanses of deep time when Earth spun silently through space, unmarked by human observation, unwitnessed by human consciousness, yet potentially very much alive, with the attention of intelligences whose origins lay among distant stars. This reversal transforms one of the most persistent questions in the search for extraterrestrial intelligence from a puzzle about contemporary absence to a meditation on ancient presence, from wondering why we don't detect signals in our radio telescopes to wondering what traces might remain from visitors who came and went long before we existed to look for them. Enrico Fermi's famous question, "Where is everybody?" assumed that intelligent civilizations should be detectable across interstellar distances, that their activities should produce signatures visible to our instruments, that the galaxy should be bustling with obvious signs of technological activity if intelligence is common in the universe. The apparent absence of such signatures has puzzled scientists and philosophers for decades, leading to numerous proposed solutions ranging from the suggestion that intelligence is extremely rare to the possibility that advanced civilizations deliberately avoid contact with developing species like ourselves. But the reversed paradox suggests a different framework entirely, one in which the signatures we should be looking for are not contemporary radio signals or megastructures visible to our telescopes, but ancient traces preserved in the geological and chemical records of our own planet. Instead of scanning the skies for evidence of current alien activity, we might need to scan the deep archives of Earth's history for evidence of visitation that occurred during the billions of years before human civilization emerged. This perspective dissolves the temporal assumption that underlies the traditional Fermi paradox, the assumption that we and hypothetical alien civilizations exist simultaneously, that we should expect to detect each other as contemporary phenomena. When we extend our temporal framework to encompass the full history of our galaxy, the statistical likelihood of temporal overlap between civilizations becomes vanishingly small, while the likelihood that numerous civilizations have risen and fallen during Earth's long history becomes overwhelming. Consider that our own technological civilization has existed for perhaps 2 centuries, and has been capable of interstellar communication for less than 1 century. Even if we persist and continue to develop for thousands or millions of years, we would still represent only a brief moment in the 4.5 billion-year history of our planet. The chances that another civilization would exist at exactly the same time within the narrow window when mutual detection might be possible are statistically insignificant when measured against geological timescales. But the chances that numerous civilizations have existed during Earth's long history, that some of them achieved the capability for interstellar travel, that some of them discovered our solar system during their explorations, become nearly certain when we consider the vast temporal canvas available for such encounters. From this perspective, the absence of contemporary extraterrestrial signals becomes not mysterious but inevitable, while the absence of any traces of ancient visitation would be the truly surprising outcome. The reversed Fermi paradox also addresses one of the most troubling implications of the traditional formulation, the suggestion that intelligence might be so rare in the universe that we are effectively alone among billions of stars. This lonely universe hypothesis has profound implications for how we think about consciousness, meaning, and our responsibilities as potentially the only self-aware beings in our cosmic neighborhood. But if intelligence is common enough that Earth has been visited repeatedly throughout its history, then we are not alone, not unique, not burdened with the cosmic responsibility of being the universe's only representatives of consciousness and creativity. We are instead newcomers to a galaxy that has been populated by awareness for billions of years, students rather than teachers, inheritors of a cosmic legacy of consciousness that extends far beyond the boundaries of our own solar system. This perspective suggests that the apparent absence of extraterrestrial intelligence in our immediate vicinity might be not evidence of cosmic loneliness, but evidence of cosmic maturity. Advanced civilizations might have developed ethical frameworks that discourage direct contact with developing species, preferring to allow natural evolutionary and cultural processes to unfold without external interference. The galaxy might be teeming with intelligence that deliberately remains invisible to us, respecting our developmental trajectory while maintaining a benevolent but distant interest in our progress. In this framework, the search for extraterrestrial intelligence becomes not a search for contemporary signals, but an archaeological investigation of our own planet's deep history, a quest to understand the traces left behind by visitors who came and went before we existed to greet them. Biosignatures of ancient guests might have briefly flourished in Earth's primordial ecosystems, exotic life forms from distant worlds that found temporary refuge in our planet's early oceans before either returning to space or quietly integrating into terrestrial evolutionary processes in ways so subtle that their alien origins became invisible to all but the most sophisticated analysis. The possibility that Earth's biosphere might contain genetic or biochemical elements that originated elsewhere in the cosmos challenges our assumptions about the isolation of terrestrial evolution and opens doorways to questions about the true diversity of life's origins. Life as we know it on Earth follows remarkably consistent patterns at the molecular level. All known organisms use the same genetic code, the same basic mechanisms for storing and transmitting hereditary information, the same fundamental biochemical pathways for metabolism and energy production. This universality has long been interpreted as evidence that all life on Earth descends from a single common ancestor, a primordial organism that emerged from the chemical soup of the early oceans and gave rise through evolution to all subsequent biological diversity. Yet, this interpretation assumes that the biochemical uniformity we observe represents the only possible solution to the challenges of organizing and maintaining living systems. What if some of the molecular mechanisms we consider universal to terrestrial life actually represent technologies, solutions to biological problems that were developed elsewhere in the cosmos and introduced to Earth by visiting life forms that briefly colonized our planet during its early history? The genetic code itself, the system by which sequences of DNA bases are translated into amino acid sequences in proteins, displays certain characteristics that have puzzled biochemists for decades. The code appears to be optimized in ways that minimize the effects of mutations and transcription errors, as if it had been designed according to principles of error correction and information stability. Some researchers have suggested that this optimization represents evidence of natural selection operating at the level of the genetic code itself, but others have wondered whether such sophisticated information processing systems might require the kind of forward planning and design that suggests intelligence rather than random mutation. Similar questions arise when we examine other fundamental aspects of cellular biochemistry. The mechanisms of photosynthesis, for example, involve quantum mechanical processes so sophisticated and precisely calibrated that human scientists are still working to understand them fully. The molecular machinery that carries out photosynthesis converts light energy into chemical bonds with an efficiency that approaches theoretical limits, using techniques that seem to anticipate and compensate for the quantum mechanical effects that would otherwise reduce the efficiency of energy transfer. Such sophistication might represent the pinnacle of evolutionary optimization, the result of billions of years of natural selection refining these systems to near-perfect efficiency. But it might also represent something else, evidence that some of the fundamental technologies of life originated in laboratories rather than in the random chemistry of primordial oceans, developed by intelligences capable of designing molecular systems with the kind of precision and foresight that evolution by natural selection cannot easily achieve. The early Earth would have provided an ideal testing ground for biological technologies developed elsewhere in the cosmos. The planet's oceans were rich in dissolved minerals and organic compounds. The atmosphere was chemically reducing in ways that would have facilitated certain types of exotic biochemistry, and the absence of complex ecosystems meant that introduced organisms would not have faced the kind of competitive pressure that makes colonization of established biospheres so difficult. Visiting life forms might have established experimental colonies in Earth's early oceans, testing the compatibility of their biochemistry with terrestrial conditions, studying the potential for hybridization between their molecular systems and the primitive chemical cycles that were already emerging on our planet. Some of these experiments might have failed, leaving behind only traces of exotic amino acids or unusual isotopic signatures in very ancient sediments. Others might have succeeded too well, with the introduced organisms becoming so thoroughly integrated into terrestrial ecosystems that their alien origins became invisible. The fossil record from Earth's earliest epochs is sparse and difficult to interpret, preserving only the most general characteristics of ancient life forms. But modern techniques of molecular archaeology are beginning to reveal information about the biochemistry of organisms that lived billions of years ago, extracting traces of ancient proteins and metabolic pathways from rocks so old that they formed when Earth was still a young planet. In these ancient molecular signatures, in these chemical fossils that preserve information about life forms that existed long before complex organisms left visible traces in the fossil record, what evidence might exist of biochemical systems that don't quite fit the patterns we would expect from purely terrestrial evolution? What stories might be told by exotic amino acids, unusual metabolic pathways, genetic sequences that seem too sophisticated for the time periods in which they appear? Tidal patterns and orbital memories might preserve evidence of prehistoric encounters in the subtle rhythms that govern Earth's rotation and its dance with the Moon, signatures written in the very mechanics of celestial motion that could persist for millions of years after the events that created them. The Earth-Moon system represents a kind of cosmic clockwork, a gravitational partnership so stable and predictable that even small perturbations in its operation might remain detectable long after their causes have vanished into history. The Moon itself holds secrets that we are only beginning to understand. Its surface, unmarked by atmosphere or weather, preserves a record of impacts and events that spans billions of years. Every asteroid strike, every volcanic eruption from Earth that sends debris into space, every unusual gravitational interaction leaves traces in the lunar regolith that can persist for geological ages. The Apollo samples brought back from the lunar surface have revealed a complex history of bombardment and chemical alteration that tells the story not just of the Moon's own evolution, but of the entire inner solar system's development. But the Moon's record-keeping capabilities extend beyond the preservation of impact craters and chemical signatures. The gravitational interaction between Earth and Moon creates tidal effects that influence not just the oceans, but the solid body of the Earth itself, causing subtle but measurable deformations in the planet's shape that vary with orbital position and phase. These tidal forces are so precisely calibrated to the Earth-Moon system's current configuration that any significant alteration in that configuration, caused, for example, by the gravitational influence of massive artificial structures in Earth orbit, might leave detectable signatures in the long-term patterns of tidal stress. Ancient visitors capable of large-scale engineering projects might have temporarily altered Earth's orbital environment in ways that influence these delicate gravitational relationships. Space-based installations, asteroid mining operations, or massive spacecraft in prolonged Earth orbit could have created gravitational anomalies significant enough to slightly alter tidal patterns, change the rate of Earth's rotation, or modify the Moon's orbital characteristics. Such effects might persist in the geological record as subtle anomalies in the patterns of sediment deposition, in the rhythmic cycles preserved in ancient tidal deposits, in the long-term changes in day length that can be measured in certain types of fossil corals and other organisms that grew in tidal zones. The Earth's rotation rate has not been constant throughout geological history. Days were shorter in the distant past, when the Moon orbited closer to Earth and tidal friction had not yet slowed our planet's spin to its current 24-hour cycle. This gradual slowing is well understood and can be predicted based on tidal physics, but the actual rate of change recorded in geological formation sometimes shows minor deviations from theoretical predictions. Anomalies that are usually attributed to changes in Earth's internal structure or variations in tidal friction caused by the changing configuration of continents and oceans. Yet some of these deviations might reflect external influences, temporary alterations in the Earth-Moon system caused by the presence of massive artificial objects in space. The gravitational field of a large spacecraft or space station, while tiny compared to planetary masses, might still be significant enough to create measurable perturbations in orbital mechanics if sustained over long periods. Such influences might be detectable as brief anomalies in the otherwise smooth progression of rotational slowing, episodes when the rate of change deviated slightly from expected patterns before returning to normal. The study of ancient tidal deposits reveals remarkable precision in the cyclical patterns that governed Earth's rotation millions of years ago. Certain types of sedimentary formations preserve daily, monthly, and annual rhythms with such fidelity that geologists can determine the length of ancient days and months with extraordinary accuracy. These natural chronometers provide a detailed record of how Earth's rotation and orbital characteristics have changed throughout geological history. In this precise record of ancient timekeeping, embedded in the very rhythms of sedimentation and fossil growth, subtle anomalies might exist that reflect temporary influences on Earth's orbital environment. Periods when the normal patterns of tidal deposition were slightly altered, when the rhythm of days and months deviated briefly from their expected progression, when something in the Earth-Moon system was temporarily different from its natural state. Such signatures would require sophisticated analysis to detect and even more sophisticated interpretation to understand. The orbital mechanics of the Earth-Moon system are complex enough that many factors could potentially create the kind of subtle anomalies we might be looking for. Changes in Earth's internal structure, variations in ocean currents, even large volcanic eruptions can influence rotational dynamics in ways that might mimic the effects of external gravitational influences. Yet, the possibility remains that some of these ancient orbital anomalies might represent evidence of visitation, traces of periods when Earth's cosmic environment was temporarily altered by the presence of technologies and installations whose scale was large enough to influence the delicate gravitational choreography that governs our planet's motion through space. The Drake equation's hidden variables multiply when we extend its temporal scope beyond the narrow window of contemporary civilizations to encompass the full span of galactic history, transforming a calculation about present-day probability into a meditation on the vast census of intelligence that might have emerged, flourished, and either transcended or quietly faded during the billions of years when Earth existed but remained unmarked by human awareness. Each variable in the equation becomes not a single estimate but a distribution across deep time, a recognition that the conditions favorable to intelligence have existed throughout cosmic history in countless variations and configurations. Frank. Drake's original formulation considered the rate of star formation, the fraction of stars that develop planetary systems, the number of planets per system that might support life, the fraction of those planets where life actually emerges, the fraction where life develops intelligence, the fraction where intelligence develops technology capable of interstellar communication, and the length of time such civilizations might persist. When calculated with contemporary estimates for these variables, the equation suggests that numerous technological civilizations should exist in our galaxy right now, leading to the apparent paradox of their non-detection. But when we modify the temporal framework to consider not just contemporary civilizations but all civilizations that have ever existed throughout galactic history, the numbers become staggering. The Milky Way is approximately 13 billion years old, and stars capable of supporting planetary systems with long-term biological evolution have been forming for most of that time. If we assume that technological civilizations emerge, persist, for some period measured in thousands or millions or even billions of years, and then either transcend their physical origins or decline into extinction, then the total number of such civilizations that have existed approaches numbers so large they lose all meaning as anything other than symbols of cosmic abundance. Consider the possibility that intelligent species typically persist for periods measured in millions of years, rather than the thousands of years that characterize human civilization so far. A species that achieves technological maturity and then maintains stable institutions for geological time periods might explore and catalog vast regions of the galaxy, visiting thousands or millions of planetary systems, establishing research stations and observation posts, accumulating knowledge about cosmic processes that spans multiple stellar generations. From this perspective, Earth becomes not an isolated world awaiting first contact, but a planet that has almost certainly been cataloged, studied, and perhaps repeatedly visited by numerous different civilizations throughout its long history. The question transforms from whether we will ever encounter extraterrestrial intelligence to how many different intelligences have already encountered us during the eons before we existed to be aware of such encounters. The hidden variable that emerges from this temporal expansion is the overlap probability, the likelihood that any two civilizations will exist simultaneously within the narrow window when mutual detection becomes possible. Even if the galaxy has been home to millions of technological species throughout its history, the chances that any significant number of them exist at the same time, within the brief periods when they might detect each other's signals, becomes vanishingly small when measured against the vast timescales of cosmic evolution. This resolves the apparent paradox of non-detection, not by suggesting that intelligence is rare, but by recognizing that intelligence might be common but temporally dispersed, scattered across billions of years in patterns that make contemporary overlap extremely unlikely. We might be living in a galaxy that has been abundantly populated by consciousness throughout its history, yet find ourselves apparently alone simply because we exist in one of the brief interludes between the flourishing of major technological civilizations. Another hidden variable emerges when we consider the possibility that advanced civilizations might develop beyond the phase of electromagnetic communication that we assume should make them detectable. Species that persist for millions of years might eventually transcend the need for radio telescopes and interstellar messages, developing forms of communication and transportation based on principles we haven't yet discovered, operating according to physics we haven't yet understood. Such post-electromagnetic civilizations might be abundant in our cosmic neighborhood, conducting their affairs according to technology so advanced that their activities remain invisible to our current detection methods. They might manipulate matter and energy at quantum levels, communicate through channels that don't involve electromagnetic radiation, travel through space using mechanisms that don't produce the kind of signatures our instruments are designed to detect. The Drake equation. When extended across deep time and expanded to include these hidden variables, suggests not a lonely universe populated by rare and isolated intelligences, but a cosmos teeming with awareness, consciousness, and technological capability distributed across temporal and technological scales so vast that our own brief moment of electromagnetic detectability represents only the thinnest slice of the total spectrum of possible intelligence. In such a universe, the question becomes not whether we will ever encounter evidence of extraterrestrial intelligence, but whether we will develop the conceptual frameworks and analytical capabilities necessary to recognize the traces of intelligence that already surround us in forms we haven't yet learned to perceive. The long silence of deep oceans, the layered ambiguity of isotopes, the fleeting signatures of vanished ages, all these linger in thought like echoes without source. Yet even as memory dissolves, the surface of the world continues to renew itself. Above stone, above tide, another layer of presence spreads outward, the green skin of continents, breathing in rhythm with light and season. To turn from the depths to the forests is to move from absence toward abundance, from the fragility of what is lost to the resilience of what still grows. And so the watchers let their attention rise once more, drawn toward the slow choreography of leaves and shadows, toward the living canopy that covers the land in shifting patterns of green. They turn toward the continents, toward belts of green that gather along river mouths and mountain flanks, toward the dark tessellation of leaves that pool in valleys and climb slopes with rain. From an unhurried orbit, the watchers let the vegetated skin of the planet come into view. The greening is not paint laid evenly across the land. It thickens where moisture lingers, thins where shadow persists, halts where salt or elevation says enough. In the far north, it swells each spring and ebbs each autumn, a gentle tide of color paced by light. In the south, where ocean rules the hemisphere, the pulse is quieter, the rhythm softer, as if the sea itself steadies the breath of land. Would they treat such rhythm as intention or as accident, a choreography or simply the consequence of tilt and weather? They do not decide. Instead, they attend to the breath of forests, carbon drawn in by day, released by night, water lifted invisibly from root to sky. Stomata open and close like tiny gates, and though no sound crosses the distance, a signature still travels outward. Minute changes in humidity, small ripples of temperature, differences in the texture of scattered light. The forest's breath does not shout. It leaves a hush in the data, a steadying hand upon the air. From their vantage, the canopy is less a sheet than a roughened sea. Shadows dapple the surface, geometry made by crowns and branches, gaps where storms or old age or fire have passed. In the balance of shade and shine, a kind of meaning hides. The proportion tells of structure. Tall trees layered over understory, young stands raw and even, old growth ragged with sun-flecked holes. Without touching a leaf, the watchers infer architecture. If they send gentle pulses and wait for the return, time filled with green reveals itself in height and depth. Ladders of wood, galleries of air, the fine lace of twigs where light tarries. They notice a small step where red light yields to longer wavelengths, a quiet edge that leaves reflect, to spare themselves excess sun. In that edge lives a flag for life, so modest it feels like courtesy. Alongside it is an even fainter glow, a breath of fluorescence as chlorophyll returns a sliver of energy to the day. No unaided eye would see it. Patient instruments do. 2. The watchers, this glow becomes a map of labor, where photosynthesis thrives, where drought presses it thin, where leaves have not yet opened after winter's pause. The world's work, written in photons too soft to be felt. Moisture rises through, leaves and becomes sky. They follow the ascent, then watch condensation bloom as clouds downwind of forests. There are rivers one can sail and rivers one can only infer. These latter run in air, carrying water from tree to cloud to rain and back to root. In some places, land behaves like its own ocean, distilling vapor and sending it inland to fall, as afternoon storms. Would they find purpose in such loops, the look of care stitched into feedbacks? Or would they see only physics arranging consequence without desire? Chemistry moves upward too. The compounds that make needles keen on the tongue and leaves fragrant in shade drift into sunlight and transform, becoming tiny grains around which droplets gather. Cloud forms a little sooner, shines a little brighter, returns a little more rain. A forest, without voice or plan, alters the sky's complexion. To distant eyes, such cohesion may resemble agreement. A million small acts producing one broad effect. Perhaps that is how intention appears when no single mind is in charge, or perhaps it is only the elegance of process, mistaking grace for will. Shadows write the hours. At noon, the canopy flattens. In morning and evening it reveals its weave. With patience, the watchers learn to read these moving veils, to tell where leaves lie broad and horizontal, where needles stack in spirals, where vines lace the upper air. Architecture answers climate's quiet questions, about wind, about light, about how long water lingers on a surface before it leaps. In the grammar of branch and blade they hear a dialect of survival, local everywhere, identical nowhere. The greening records history as well as weather. Pollen settles into lakes and bogs, minute and armored, a rain of memory that becomes a layered script. Waxes from leaves wash downslope to deltas and sea, holding in their hydrogen the taste of rainfall from the year they grew. Charcoal threads mark summers of fire. To the watchers, these archives resolve into likelihoods rather than certainties. Here a forest once advanced, here it retreated, here it paused at the lip of ice. The map of life is not fixed. It shivers with climate. It drifts with time. It answers to mountains that rise and rivers that change their minds. Edges tell another story. Some boundaries curve with rivers or lie at the foot of ranges. Others look disconcertingly straight, crisp as if drawn, angular against the softened geometry of growth. The watchers notice such edges and do not insist upon their cause. Lightning can cut a line. Wind can shear a band. Insects can carve sudden borders. Ice can score margins as clean as any blade. And yet a thought lingers gently. Some edges may be chosen, made by mouths that graze and beaks that browse, by fires set often and stopped abruptly, by patterns that repeat with a cadence not entirely the planet's own. The line between intent and influence blurs, and they let it blur. Color is not one green, but many. Young leaves hum almost yellow. Old leaves deepen toward blue. Wet canopies darken, dry ones pale with dust. In drought, the faint glow of work dims. In monsoon, it swells. A single number could stand in for this richness, rising and falling with vigor, but numbers cannot carry scent or shade or the hush that gathers under a storm-heavy crown. The watchers keep both. the measure and the feeling, the curve and the quiet. Balance returns as a theme. Forests take carbon from air and store it in trunk and root and soil. Fire, insects, rot, and wind return it. Over centuries, a living equilibrium persists, shifting yet resilient. On longer scales, ice presses equatorward and the green retreats. Warmth comes back and it advances, seeding old ground with new shade. To call this intention would be to grant purpose where perhaps there is only coherence. To call it accident would be to miss how cycles lean upon one another like stones in an arch, each holding the other up without knowing. Sometimes they see scars, broad, pale swaths where green once ruled, patterns shaped by heat and dry wind. Sometimes they see recovery, mosaics of first colonists, a lace of shade knitting year by year, the slow darkening that means roots have taken hold. Regrowth writes patience into land. The planet seems to say, nothing stays, and yet so much returns. If they have known forests of their own, the watchers may feel a kinship that needs no words. If they have not, they still recognize function. A global organ that moderates heat, returns water to sky, holds soil to hill, softens flood, slows wind, and feeds the many with the work of the few. Whether or not intention lives here, consequence surely does. The greening of continents alters the fate of air and river and stone, and so they keep watching. They let the shadows of forest breath pass across the hemispheres in waves, a slow inhalation and exhalation stitched to the length of day. They do not resolve the question. They let it rest like shade at noon. Is this choreography or consequence, plan or pattern? Perhaps the planet answers by continuing to be green when it can, brown when it must, and silver with frost when angle and cold agree. The world turns. Belts of color drift slightly with each year. The watchers, patient as ever, allow the possibility that life's quiet coherence can resemble intention without requiring it. Leaves gleam, fade, return. The air brightens, dulls, brightens. Breath goes out, breath comes in. The watchers turn their focus now beneath the canopy, beneath the dunes, beneath the waters, to the fragments of bone and shell pressed into stone. Fossils lie scattered across the continents, waiting within cliffs and riverbeds, sealed in sediments, resting in quiet abundance below the surface. From orbit, these relics are invisible. Yet patterns in geology, in strata tilted and lifted, hint at their presence. With patient inference, the watchers understand. This planet holds memory not just in air and ice, but in the shapes of vanished creatures. Would they see fossils as a kind of language? Each imprint of a leaf, each spiral of a shell, each skeleton preserved in limestone is a word in a vocabulary that life has been speaking for hundreds of millions of years. The dictionary is immense, but incomplete, its pages torn and scattered. Entire chapters are missing, erased by erosion or subduction. Still, what remains suggests a tale of restless experimentation. Forms blooming, diversifying, disappearing, only to be replaced by new ones, as though life itself is a restless artist, always sketching, always discarding. They may notice patterns across time, long stretches of stability, then sudden extinctions. Afterward, renewal. Creatures stranger, larger, smaller, more intricate. Trilobites vanish, ammonites flourish, reptiles rule, mammals wait, birds rise, flowers spread. Each layer contains a cast that is unique, yet linked to those before and after, a continuity stitched with abrupt breaks. Would they wonder whether intelligence was inevitable, or only one possibility among countless abandoned experiments? The watchers may linger on the forms themselves. Spirals recur, shells curled inward with mathematical grace. Symmetry dominates. Bilateral bodies, radial corals, fractal fronds, Repetition suggests efficiency, but also something deeper, perhaps a universal tendency of matter and energy to find elegance. Would they mistake these patterns for intention? Or would they understand them as echoes of physics, the geometry of growth written by chemical gradients and biological constraints? Among the fossils are stories of adaptation. Fins become limbs, scales become feathers, jaws become tools for grazing, hunting, chewing. Every innovation is provisional, carried forward only if it fits the shifting stage of climate and habitat. The watchers might see this as improvisation, a dance with geology and atmosphere, a dialogue without words. Would they notice how few of these experiments endure? Of all the species that ever lived, nearly all are gone. Extinction is the rule, survival the rare exception. Earth's library is vast, but most of its books have already closed. To patient eyes, this may seem natural, even inevitable. Life is abundance, but also disappearance. Do fossils hint at awareness? They do not speak, do not build, do not signal. They lie still, silent outlines in stone. Yet some forms suggest possibility. Brains encased in skulls, hands capable of grasping, eyes forward-facing, social herds implied by trackways and nesting sites. Would the watchers wonder if these forms ever took the step from instinct to reflection? Or would they see intelligence as one more experiment, fragile and uncertain, perhaps no more destined than the trilobite's armor or the ammonite's coil? The watchers may imagine the world as it once was, seas warm and shallow, forests of ferns towering in humid air, deserts filled with reptiles, skies with wings broader than human houses. They may try to feel what it was like to stand in such eras, to hear no voices but the calls of animals, to see no buildings but cliffs and trees, to sense a world where everything is alive yet nothing speaks in the way we now speak. And perhaps they would ask, if we, the present inheritors, someday vanish, will our traces be as faint? Will our bones, too, lie pressed in stone, scattered and partial, unread except as curiosity? Will our cities be reduced to odd layers of mineral, our machines to rust, our plastics to faint chemical threads? In time, will we join the same silent record, indistinguishable from the countless others who came and went? The fossils remind them, and us, that permanence is an illusion. Life's abundance is matched only by its transience. Every form, no. Matter how dominant becomes memory. Every memory, no matter how sharp, becomes dust. Yet within this cycle, there is beauty. The watchers recognize that even silence speaks, that fossils are not merely the end of life but its continuation in another form, life transmuted into stone, enduring long after the breath has gone. And so they linger, attuned to the fossil. Murmurs, hearing in the quiet stone the faint echoes of wings, fins, claws, and leaves. Earth tells its story softly, but it tells it still. The watchers drift lower, their perception brushing the surface with patient care. From above, the land is patterned with hollows and circles, ridges and plains. Some are scars of impacts, craters left by wandering stones from the deep. Others are the work of erosion, valleys carved by rivers, basins hollowed by ice. Yet in some places, the forms might seem ambiguous. Would they wonder whether certain patterns are natural or the remnants of something built, something left behind? Ruins and craters resemble each other more than we might wish. A collapsed city, if buried beneath sand, could appear as a depression, a faint geometry that mimics the shape of an impact. Likewise, an ancient crater filled and eroded might resemble foundations, the remnants of walls long gone. From orbit, certainty blurs. Would the watchers confuse one for the other, just as we sometimes do? Stone circles appear across continents, built by erosion, tectonics, or by the slow work of lava cooling, yet they echo the forms that civilizations often favor: symmetry, enclosure, repetition. Would the watchers sense intention in these patterns? Or would they hold back, knowing how easily the mind finds meaning in shapes that carry none? The ambiguity deepens with scars of war in geology. Rivers split and rejoin, leaving oxbow lakes shaped like crescent moons. Wind scours rock into lines, parallel and precise. Salt pans gleam in polygons under the sun. All natural, all without mind. Yet, to eyes unfamiliar with earth, they may resemble deliberate markings, the trace of a hand that never was. Would the watchers lean closer, searching for confirmation? Fragments of metal, isotopes unusual, alignments too exact to ignore. And if they found none, would they let the question remain? Or would they decide that no ruins stand here, only craters, only erosion, only the indifference of geology? Perhaps they would reflect upon their own worlds, their own ruins. Do their histories also dissolve until only faint geometries remain? Have they ever mistaken craters for cities, or cities for craters? The distinction may matter less across deep time than it seems to us. What was built can collapse. What collapsed can appear natural. What is natural can be mistaken for design. From orbit, the watchers see ruins in potential everywhere. A mountain chain could be walls. A river delta could be streets. A pattern of ridges could be foundations. Yet they do not conclude. They allow the possibility to exist alongside the likelihood of geology. Would they wonder at the absence of certainty? Would they find beauty in ambiguity itself, that Earth remains unknowable even under their patient study? Perhaps. For certainty ends a story, but mystery lets it continue. The watchers drift, and Earth turns. Craters glint with shadow, valleys stretch in quiet, deserts ripple with wind. If ruins lie hidden, they remain unspoken. If no ruins ever existed, the shapes are still beautiful. In either case, the planet keeps its secrets, and the watchers accept them. The watchers turn their gaze toward the oceans again, not only as surfaces of light and movement, but as vaults of memory. Beneath their rolling skin, the seas hold stories. Longer than continents, deeper than mountains, broader than forests. Oceans are not merely water, they are archives, guardians of secrets, keepers of civilizations, whether real or imagined. Would the watchers imagine them as memory itself? Every current, every swirl of salt, every buried layer of sediment holds record of what has passed. Rivers carry soil, ash, and bone into the sea, where it settles as quiet layers. Over millions of years, these layers accumulate like pages in a book too vast to ever be read fully. If they could touch the deep, they would find the remains of creatures too small to see, piled endlessly into strata that tell of climates, extinctions, and blooms of life. But the oceans also erase. Salt water dissolves, currents scatter, pressure crushes. Wood and bone decay swiftly. Metals corrode, structures collapse beneath weight and tide. If an ancient civilization had ever risen, might the sea have swallowed it whole? Would its ruins, its ports, its machines lie scattered under silt, unrecognizable as anything more than stone? The watchers may wonder, how many times has the shoreline shifted, covering what once stood in open air? During ice ages, seas retreated, exposing vast plains where now only water lies. During warm epochs, oceans rose, drowning coasts, burying forests, hiding valleys beneath waves. Entire landscapes disappear this way, and any memory written upon them vanishes with them. The ocean does not keep everything. It chooses. Would they read the chemical record in its depths? In shells of plankton, oxygen isotopes reveal the temperature of the sea when they formed. In layers of sediment, iron and sulfur trace the breath of ancient microbes. In bands of black shale, Sudden death events speak of anoxic waters, lifeless seas that once stretched wide. Every layer is a message, but in a language not easily translated. Perhaps they would listen for sound. Earth's oceans hum with life and motion. Whales singing, fish clicking, waves grinding sand against shore, currents roaring in deep valleys. To our ears, these sounds are immense. To theirs, they may be faint signatures, hints of activity without identity. Would they wonder if such noises ever carried meaning, or if they are only the echoes of a restless sea? Oceans also carry traces of what has touched them. Plastics, metals, hydrocarbons. In our age, they are new signals, drifting across gyres and sinking into abyssal plains. To the watchers, even these may be ambiguous. Are they natural polymers, rare eruptions of chemistry, or are they signs of intention, fleeting footprints of a civilization not meant to last? Would they imagine the oceans as a kind of graveyard, where not only species but entire epochs vanish into obscurity? Perhaps they would, and perhaps they would recognize that such vanishing is part of life itself, that memory need not be permanent to be meaningful. Still, the seas offer beauty beyond their ambiguity. From above, sunlight glints, storms gather, waves spread outward in concentric circles. From within, waters circulate heat around the globe, carrying warmth from tropics to poles, ensuring no place is wholly cut off. Oceans are both archive and engine, preserving while also creating, holding memory while shaping the present. Would the watchers feel awe at the scale of this? An entire planet bound together by water, each drop, connected to every other, circulating endlessly, erasing and remembering at once? Perhaps. For to discover Earth first is to discover not only stone and air, but the deep, unfathomable silence of oceans, where memory both survives and dissolves. And so they linger, sensing the seas as more than surface, more than depth. They sense them as memory itself, vast, patient, ambiguous, and alive. The watchers drift in orbit, attuned now to silence of another kind. They have studied oceans, forests, rocks, and skies, yet there is another way a world might reveal itself. Through deliberate transmission. They turn their senses outward, listening not to the planet itself, but to the space around it, waiting for signals that rise above natural noise. What do they hear? The steady hiss of a star's wind, the faint chorus of the magnetosphere, the crackle of lightning storms below, bursts of radio-like emission from auroras at the poles. All these are natural, all part of the planet's background song. But do they hear anything more? A pattern too regular, a rhythm too sharp, a signal that cannot be explained by storm or stone? They listen long. Silence persists. Would they be surprised by the absence? Perhaps not. They know that civilizations, if they exist, may not speak loudly, may not speak at all. To shout across the cosmos requires energy and intent, both rare. Many worlds may live and die without ever broadcasting. Others may have spoken, but only briefly, their voices already faded into static. Still, they test the silence. They search across bands, from low frequencies to the finest needles of light. They look for pulses, repetitions, harmonics. They watch for the unmistakable symmetry that intention creates. They may even search for artifacts in orbit, glints of metal, fragments drifting. Yet all that greets them is the calm of nature, the rhythm of lightning, the hum of ions, the background of the galaxy itself. Would they then wonder if intelligence has not yet arisen here? Or would they allow the possibility that it has, but has chosen not to speak? Silence is ambiguous. It can mean emptiness, or it can mean restraint. Perhaps they themselves once chose silence, knowing the risks of speaking into a universe they did not yet understand. They might recall their own first transmissions, the tentative signals they sent into the dark, and the long ages after when. Those signals seemed futile. Perhaps they remember the moment they ceased broadcasting, realizing that endurance mattered more than announcement. If so, they would recognize Earth's silence not as absence, but as possibility. Would they also consider timing? A planet is vast in time, but a civilization brief. The chance of arriving during the narrow span when signals are strong may be small. To visit Earth now may mean arriving too early or too late. Silence does not answer which, the watchers do, not despair at silence. They know it carries meaning, too. A quiet planet is still a living one, still a place of water and forest and change. The absence of signal does not diminish its wonder. It only deepens its mystery. And so they linger, listening still, letting silence speak. They begin to wonder about implements. Not only bones and leaves and teeth shaped by evolution, but objects shaped by intention, edges made sharper than weather would allow, forms coaxed into function by minds that anticipate tomorrow. From miles above, tools are invisible. Yet, signs of them might ripple outward, subtle and indirect, like the way wind reveals itself by the bend of grass. Would they imagine hands here, or something like hands? Talons, beaks, fins, tentacles, any limb that can hold and turn and test the world. They do not bind tool to flesh the way we do. To them, a tool is a relationship, not an object, a loop where matter and intention meet for a while and then let each other go. The loop might belong to primate fingers or to clever beaks. It might belong to a striped snout patting the seafloor with a sponge. It might belong to soft arms rearranging shells into a den. Tool, in their way of thinking, is a pattern of cause that repeats. If they picture hands, they do so gently, knowing that grasp is only one path toward manipulation. They imagine corvids bending twigs into hooks, imagining cetaceans wearing sea sponges like gloves to protect tender skin while foraging, imagining octopuses carrying coconut shells as portable shelters. Even plants alter flows. Roots cracking, rock exudates recruiting microbes, thorns redirecting grazers, vines using other bodies as scaffolding. None of these are tools in the narrow sense, yet all change the terms of the world. Where does made end and used begin? The boundary softens under patient eyes. Still, some marks would be unmistakable if one could see them up close. Bones with parallel microstriations where sharp edges have sliced flesh. Stones fractured with conchoidal curves. Flakes scattered, in rings where a napper sat. Soils reddened and magnetically altered by sustained low fire. Pigments ground fine and carried to rock in deliberate strokes. Fibers twisted into cords. Holes bored in shells and teeth not by predator, but by purpose. But from orbit, these specificities dissolve into landscape. The watchers must rely on inference, not evidence held in hand. Would they search for the echo of warmth in places where warmth should not hold? Small, persistent hotspots beyond the measure of volcano or peat fire, the faint signature of hearths multiplied through. Valleys and along river terraces, they could imagine evenings repeated for generations, flame coaxed from friction or struck from stone, heat gathering people toward its patient light. Yet fire is not the gift of oceans. It belongs to air and dry places, to oxygen and season. If the first toolmakers dwell in water, how would heat join their story? They might master pressure, sound, electricity, chemistry, light, languages as deft as flame, without flame's trace. Would they look for patterns of prey bones gathered, where they would not gather by chance? For layers where one species appears consistently with fractured long bones and split marrow, for shell middens rising like low hills that tide alone could not build? Could they see, in the geometry of refuse, a mind sorting, a hunger planning? Or would time topple these small monuments and leave only math behind? The deep ocean swallows mounds without ceremony. Rivers scatter order as easily as they make it. Metals speak another dialect. Copper native and soft, meteoritic iron hammered cold, later ores smelted, slag pooled black beside vanished furnaces. A civilization that masters metallurgy lets certain isotopes wander from stone to air to body. Lead and mercury move in ways geology rarely permits on its own. From above, perhaps these signatures would appear as smudges against background orders, like ink diffusing in clear water. Yea, but smelters demand fuel. Fuel needs forests. Forests once cut, regrow, or recede. Rain carries residues away. Tectonics buries what rain cannot carry. Even metal forgets itself across ages. They might consider an intelligence that remains small, local, quiet, never scaling its tools beyond the intimate. Needles of fishbone, awls of thorn, hooks of shell, baskets of reed, resins for glue, stains for skin, music made on hollow reeds, an entire culture of making that leaves almost nothing for the far future to find. If so, the planet could have held long conversations between matter and mind, all without raising a mark larger than a fire ring or a trail. Would such a conversation count for less? Or would its lightness be another kind of mastery, a way of living that declines to shout? They contemplate forms that cannot hold flame, yet can hold thought. Wings that fold, but fingers that do not. Beaks clever enough to shape, but bodies too light to carry much. Minds in water that sense with sonar and scatter meaning through clicks and whistles, drawing maps of echo and depth and kinship, a technology of sound within a medium that erases artifacts as quickly as it spreads messages. Could tools evolve as patterns in social memory rather than as objects? Could knowledge be the tool and the world remain materially unmarked? If they have known other ecologies, the watchers recognize that constraints shape possibility. Eyes that face forward lend depth, but eyes on the side lend vigilance. Neither demands thought, but both permit it. Digits that oppose allow grasp, but suction and friction and torsion accomplish similar ends. Fire wants air, chemistry wants containers, mathematics wants minds and time. Any of these could appear under multiple anatomies. The notion that hands are required softens. What is required, perhaps, is feedback, a loop where the world answers and the answer invites another question. They search instead for loops, paths that repeat along riverbanks more than animal traffic would suggest, quarries that open and then move as if following a vein, stripes of cleared ground in mosaics that otherwise obey only water and soil, low earthen rises that follow contour, rather than dune. But erosion loves slope. Rivers love shortcut. Termites raise mounds to breathe. Beavers flood valleys to engineer wet meadows filled with fish and frog and willow. Architecture spreads through the animal world like a quiet. Art, intent becomes hard to rank. What is a tool when a creature is also a builder of worlds? Coral polyp by polyp. Reef rises, altering currents, refracting light, setting nurseries for countless young. Forests darken air and call rain. Worms ventilate soils, changing the chemistry of the ground itself. Beavers interrupt rivers and, in doing so, feed entire valleys. The watchers see that the planet already wears artifacts, but they belong to life at large. If they seek the special case called civilization, they must look for acceleration, for change piled quickly upon change, for feedbacks that outpace climate's patient pace. Even acceleration may hide within other oscillations. A brief era of controlled fire might resemble a cluster of drought years. A century of metal vapor could mimic the breath of volcanoes. 1,000 years of forest cutting could blur into a shift in wind. Timelines folded into rock compress the signatures. Singular excursions flatten into wiggles inside larger noise. If the watchers conclude anything, it is that intention is easiest to see near its making, and hardest to see in sediment. They allow their minds to make gentle sketches, hands napping in river light, mandibles choosing twigs, arms assembling, shells in a dim grove, a pod of sleek bodies exchanging tools of sound in deep canyons of water. They resist the urge to prefer one sketch over another. The planet does not choose for them. It offers hints and then erases. If tools once proliferate here, they might do so again. If they never did, the world remains no less whole. The Watchers care less for verdict than for possibility. Tools are one way matter learns itself. Life is another. Time is a third. Each in its turn builds a bridge between what is and what could be. Bridges do not always leave pylons when the river rises. In the quiet, they return to what can be known from above. Subtle heat, subtle order, subtle breath. They let go of the wish to hold a knife or feel a polished handle. They accept that on this first meeting, the enigma of tools will remain an enigma, tender and unresolved. The blue world turns beneath them. Wings fold and open. Fins write arcs into water. Leaves make more leaves. If hands exist here, they have not yet waved. If they once did, time has taught the planet to keep their memory gentle. The Watchers, patient as always, allow the question to rest in the space between wing and limb, between stone and thought. They turn their attention toward pattern, toward the quiet grammar that runs through leaf and cloud and stone. Symmetry appears first, as it often does, because symmetry is patient and easy to meet. A flower opens and repeats itself around a center. Snow accretes and repeats itself around a crystal seed. Insects mirror themselves across a thin line of body, wings matched like folded thoughts. Even the coastlines of frozen lakes fracture into geometric plates under the weight of winter. To the Watchers, such repetitions are not declarations, but invitations. Order, offering a calm place to rest the eyes before the wilder parts of the world resume. Would they take symmetry as intention? They hesitate because nature makes symmetry, without asking permission. Water favors sixfold snow because its bonds lean that way. Basalt cools into columns because stress seeks the shortest path to rest. Bees build hexagons because space and material conspire toward efficiency. And bodies repeat a task until it becomes an architecture. There is a purpose in each example, but the purpose belongs to physics and habit as much as to thought. They let the recognition settle. Pattern is not proof. Pattern is a possibility. Still, they search gently for signs that depart from the easy, ways matter organizes itself. Spirals occur where growth adds without losing form. In shells that widen as creatures age, in seed heads that pack space with extraordinary thrift, in cyclones where pressure curves wind around a calm eye. They expect spirals and find them. They expect stripes where two substances repel one another in alternating bands, and they find those too. On the coats of mammals where pigment cells chase and avoid, in dunes where turbulence writes wind, into sand, in shallow seas where light and nutrient draw algae into rhythmic patches. Regularity appears again and again without needing a planner. They look for primes not because nature forbids them, but because life rarely falls into the cadence of prime intervals by accident. A chorus of pulses that repeats every 11 heartbeats and then changes might ask to be heard. A flash that returns at intervals that resist tidy division might be more than weather. They listen for such cadences and hear instead the planet's familiar polyrhythm. Tides pulling in two bodies' time, seasons counting tilt, storms ticking to the metronome of heat and topography. Each beat belongs to a cause that explains itself without reference to mind. Silence persists where intention, if present, might have chosen to step forward. They attend to chirality, to handedness, because it is a subtle symmetry's refusal. Molecules twist, light spins. Shells coil left or right. Vines prefer one climb over another. Life here, if like life elsewhere, might favor one hand in its building blocks. A bias that begins small and then spreads until whole ecologies inherit the same turn. That, too, could arise without a plan, a local accident amplified by time, and yet an organized global reversal might be difficult to explain without touch. They test for such reversals and find only the local patchwork of chance, mixed shells in tide pools, mirrored twists in seeds born by different breezes, no worldwide decree. They let their thoughts pass over the clouds. Convection arranges into cells and streets, into open and closed rings, into polygonal fields that resemble tiled floors. Lightning favors fractal paths, branching where resistance narrows, each spark a temporary tree that burns backward into air. River networks do the same, carving hierarchies of streams that marry in predictable ratios. If a grid were to appear, crisp lines at right angles repeating over miles, it could mean many things. Crystals rising from a drying lake, cracks spreading on a cooling plain, or the echo of a survey. From here, though, grids dissolve, quickly into the messier precision of erosion. The watchers keep their distance and their patience. In the high latitudes, ground freezes and thaws and freezes again. Stones creep outward from repeated swelling and relaxation until circles form, tidy rings of rock and soil. The planet makes these bracelets in silence. Elsewhere, wind combs grasses into waves that break on invisible shores, sea ice fractures, into schools of pale lozenges. Salt dries in pans and draws tight angles with the draftsman's confidence. Everywhere they look, pattern offers itself, and everywhere it bears no need for authorship beyond temperature, time, and the way small. Forces add. They consider the sky beyond atmosphere. Rings around distant worlds settle into divides where gravity sings different notes. Storms on gas giants anchor into latticed flows, sometimes fixing hexagons at poles where currents fold back on themselves. Galaxies twine into spirals because angular momentum and density waves negotiate. The universe makes geometry not because it chooses beauty, but because beauty is often what stability looks like when it stands still long enough to be seen. If intention leaves a mark, perhaps it lives not in symmetry alone, but in departures from what symmetry would choose. A river forced to run straight for a long reach despite a landscape that asks it to meander. A sequence of clearings along a contour where soil and slope would not produce them. A regularity that adapts across scales, changing just enough to keep itself intact when conditions shift quickly. They look for such adaptive repetition, and yet the beaver already builds it. The termite already cools its cathedral with vents. The coral already branches with rules that vary to keep light within reach. Architecture is old, older than any hypothetical civilization they might imagine. What then distinguishes civilizations from the architecture of life at large? Acceleration, perhaps. The way pattern multiplies upon pattern until feedbacks pull the present away from the slow equilibrium that would otherwise prevail. Growth that refuses to saturate. Edges that remain sharp against erosion longer than they should. Signals that hold their shape across noise that would ordinarily dissolve them. They search for this acceleration in canopy and coast, and they find it mostly where climate has pushed and been pushed back, margins of advancing desert, forests responding, ice retreating while currents adjust. Quick for geology, slow for history, comfortably ambiguous for any verdict. They entertain the thought that intelligence might prefer asymmetry, might celebrate irregularity as a signature of taste or freedom, deliberately breaking the expectations of nature as a way of being seen. But taste itself evolves from constraints, and freedom often chooses comfort with the patterns that keep life steady. A maker of worlds might decide to lean on geometry because geometry saves work, saves energy, saves time. In that case, intention vanishes into efficiency and resembles everything else the planet does when left alone. If they have a language of measure, they might talk among themselves of compressibility, of how easily a description shrinks. A coastline that refuses to be summarized, that retains complexity no matter how it is sampled, suggests turbulence or time. A signal that compresses unusually well might be contrived. They test small parcels of data this way, and they find what oceans and forests usually offer: richness where inputs collide, simplicity where constraints dominate, nothing that insists on being read as a message meant to travel. They do not feel disappointment. Pattern without proclamation remains generous. It offers comfort to the mind, a sense that amid chance there is grammar, amid flux there is form. They let symmetry teach them about forces they cannot touch. They let asymmetry remind them that life resists perfect repetition because novelty shelters resilience. And when they finally pull back from their analysis, they keep a few images close: the even spacing of dunes along a wind corridor, the slow spiral of a cyclone unbraiding over warm sea, the filigree of river ice cracking in early spring, the tiled calm of a salt flat at dusk. These are sufficient. If intention is present on this world, it hides inside process that would happen, anyway, like a melody woven into the noise of rain. If intention is absent, the rain still plays. They return to the quiet posture that suits them. Pattern remains a question with gentle edges. It does not demand more than attention. The blue planet turns, stitching symmetry into its days and letting. The stitches loosen where time pulls. The watchers breathe the order in without owning it, satisfied to let beauty and physics be indistinguishable for now. The watchers drift a little farther from the bright curve of atmosphere, and in that distance, the sense of history grows stronger. Not the history of centuries, nor of dynasties or migrations, but of epochs. Long unwritten chapters that slip between the layers of stone. Earth carries these epochs like forgotten verses, entire spans of time folded beneath new soil and new seas. To us, they are hidden. To the watchers, they are questions waiting in silence. Would they see the gaps as clearly as we do? Even our sciences speak of them openly. Unconformities, places where rock should have been but is not, where millions of years are missing from the page. An ancient shoreline washed away, a mountain raised and eroded, a basin filled, and then emptied. These voids remind us that the record is never complete. To beings who measure time in aeons rather than moments, would such absence be unsettling, or would it feel inevitable? Perhaps they would consider the possibility of lost worlds, ages of flourishing life that left almost nothing behind. Not all creatures fossilize. Not all landscapes preserve their stories. Most of what lived here is already forgotten, dissolved before it could be remembered. Would the watchers imagine what kinds of life might have slipped through the cracks? Shapes stranger than trilobites, minds stranger than our own, leaving no trace but a chemical shadow blurred into stone. They might wonder whether intelligence itself could vanish into one of these gaps. If a civilization rose and fell during such an unwritten epoch, what would remain? A thin anomaly in carbon, a scattering of metals that resemble ore more than artifact. Perhaps even nothing at all. Earth is adept at erasure. Given enough time, it forgets even its greatest upheavals. Would they then reflect on their own histories? Do their worlds, too, contain gaps, centuries or millennia of which nothing survives? Perhaps they know the frustration of trying to peer into darkness where no evidence shines. Perhaps they understand that to study a planet is always to read a fragmentary manuscript, pages torn and burned, rewritten and erased. The watchers let. Their gaze travel over deserts and oceans, mountains and plains, knowing that beneath every visible feature lies the invisible past, rivers that no longer flow, forests that no longer stand, creatures that no longer breathe. Each moment of earth carries countless ghosts, not in spirit but in absence, in the silence where their presence once was. Would they see beauty in this incompleteness? Perhaps, for to know everything is to close the book. To leave space for the unwritten is to keep wonder alive. The gaps themselves become invitations, not failures of record, but openings for imagination. And so they drift, unhurried, letting the unwritten epochs remain unwritten. The earth does not apologize for its silence. It simply turns, carrying its gaps with grace, holding its mysteries intact. The watchers, having lingered with stone and ice and silence, return once more to the air, not for its steady balance, nor for the archives it preserves, but for its suddenness, the flicker of change written faster than geology, swifter than ice. To them, the atmosphere is not only a veil but a pulse, a screen upon which abrupt stories appear and vanish. They notice how gases rise and fall with the seasons, a breath almost predictable. But within these regular tides there are moments of disruption, spikes of carbon, sharp dips of methane, abrupt changes in trace, compounds that should have remained steady. Would they see these as ordinary, the product of eruptions or fires, or would they imagine signals, fleeting attempts to speak? A volcanic plume can mimic the breath of industry. A wildfire can alter the chemistry of continents. A comet's passage can scatter dust into the upper air, changing its transparency. Each of these is natural, yet each resembles intention when viewed from afar. To interpret is to risk error. The watchers know this well. They might pause at anomalies, a sudden enrichment of carbon isotopes, a faint excess of nitrogen oxides, patterns of chlorofluorocarbons or other molecules not easily made by geology alone. Would they lean closer, considering whether these are messages or only the brief exhalations of the planet's restlessness? If they are cautious, they may remind themselves, chemistry can deceive. Evidence is ambiguous. Interpretation, fragile. To believe too quickly is to mistake noise for meaning. Yet to dismiss too quickly is to miss what may be rare. The truth lies somewhere in the stillness between certainty and doubt. Would they consider that signals need not be deliberate at all? That a civilization, if it exists, may alter its air without intending to? That its industry may write messages in the sky simply by being, by burning, by building, by changing? To the watchers, the line between signal and side effect may not matter. Either way, the air is marked and the mark is readable. Perhaps they recall their own histories, times when their skies shifted abruptly. Did they once scar their atmosphere with sudden chemistry? Did they learn to read such scars as warnings, as reminders that every action lingers longer than the one who acts? If so, they may view Earth's flickers with empathy rather than judgment. They might also consider scale. A spike that feels vast to us may appear tiny against the backdrop of aeons. Our centuries of industry are but a breath in geological time. Would they even notice us? Or would our imprint vanish into the noise of volcanoes, of forest fires, of impacts? The difference between signal and accident narrows the farther one stands from the source. Still, the watchers continue their patient survey. They watch for regularity, for repetition, for any pattern that suggests not just chance but continuity. If the flickers repeat with rhythm, they may begin to wonder. If they appear only once, they may pass without comment. Earth offers both, a mixture of chaos and order, of accident and cycle, leaving interpretation open. In the end, they may accept that the atmosphere is both a diary and a canvas, recording and erasing at once. Its flickers are neither proof nor denial, but gentle provocations. To notice them is enough. To let the question remain is wisdom. And so the watchers drift onward, letting the air's brief signals fade into the quiet background of stars. The watchers let their gaze slip downward again, to the crust of the planet, to the broken stones and weathered shapes that rise above plain and valley. From a distance, they resemble ruins, arches of rock, pillars standing alone, walls of canyon carved so cleanly they could be mistaken for masonry. To us, they are monuments of erosion. To them, they may carry the question of builders. Wood. They step closer in thought, wondering if these lines and angles are deliberate. Wind carves alcoves into cliffs, leaving chambers half enclosed. Lava cools into hexagons, columns neat as architecture. Rivers gnaw through stone until arches remain, fragile spans suspended like bridges. All natural, yet all evocative. To unfamiliar eyes, could these not seem like remnants of intention? If they sought evidence of makers, what would they find? No tools remain, no scaffolds, no carvings that persist beyond the wear of time. Only forms that suggest possibility. The watchers know how easily perception invents meaning. A shadow here, a right angle there. The mind fills in a story. But they also know that even ambiguity has value. It teaches humility, a reminder that not all questions are answerable. Would they imagine walking among such formations, wondering whether they were homes, temples, towers? Would they imagine voices echoing where now only wind passes? Or would they resist the urge to populate these stones, accepting them simply as they are? Ruins without builders, architecture born of chance? In deserts, they would find cairns of stone left by frost and heat, stacks that seem intentional. On coasts, sea cliffs collapse into terraces, resembling platforms or roads. In mountains, ridges align into straight horizons, as if walls had been raised. Yet all belong to geology, the quiet labor of water, wind, and pressure. The planet itself is the architect, building without plan, destroying without regret. The watchers may think of their own ruins. Do they still stand, or have they too been swallowed by time? Do they know how quickly cities dissolve, how fragile even the strongest material is against water and heat? If so, they would recognize how easily ruins blur into nature, until nothing remains but ambiguous shapes. Perhaps they would accept the ambiguity as part of Earth's beauty, that to wonder whether stones were raised by hands is to be invited into the deeper truth. Everything here is temporary. Even what seems permanent will fall, and what has fallen may one day be mistaken for natural. Would they feel disappointment at the absence of certainty? Or would they feel reverence for a world that keeps its secrets? A planet that allows its surface to suggest stories without confirming them. A planet that lets imagination participate in its reading. Ruins without builders may be more powerful than ruins with them, for they remind the watchers that intention and accident blur over time. That meaning can emerge without design. That mystery itself can be the gift. And so they drift on, letting the stones remain as they are, suggestive, silent, beautiful, in their uncertainty. The watchers drift once more to the oceans, but now their attention rests not on depth or chemistry, not on sediment or memory, but on the simple play of light. At certain angles, when the star leans low and waves lie tilted, the surface becomes a mirror. Bands of brightness spread outward like spilled silver. From orbit, the glitter is unmistakable, a moving patch of brilliance sliding across seas with the turning of the world. Would they linger on this reflection, wondering whether it means more than physics? Specular glint is expected where liquid spreads smooth enough to shine. Yet the quality of the shimmer is different from the cold steadiness of ice or the sharp glare of salt flats. It flickers, dances, scatters. It suggests motion beneath, a surface restless with wind and tide. Would they imagine that this glitter could be alive? a sign not merely of water but of activity. From high above, the reflection moves like a language. The position of the sun, the angle of the planet, the roll of the sea, all combine to shift the patch of light across vast distances. It never repeats exactly. To patient eyes, the glint may resemble a signal, not regular, not coded, but still, persuasive. A planet that flashes back at its star endlessly as if acknowledging the light it receives. Would they wonder if life has learned to use this shimmer? On our coasts, fish, schools, and seabirds flash in coordinated arcs, their scales and wings reflecting sunlight in sudden bursts. Even forests glitter faintly when leaves turn at once in the wind. Could they mistake these scattered reflections for something intentional, a flicker meant to be seen? Or would they recognize them as coincidence, beauty without message? They might notice how oceans change color with angle and depth. In shallow waters, turquoise gleams. In deep, the blue darkens until almost black. Phytoplankton bloom and turn patches green, then fade, leaving swirls that resemble brushstrokes across canvas. Would they see art in this, or only chemistry? Would they pause to imagine how creatures within respond to such changes, chasing or fleeing blooms as though following invisible trails? Clouds sometimes cover the glitter, softening it, scattering light into diffuse haze. Yet even this has pattern. Openings in cloud allow sudden beams to strike the sea, brightening one region, while another stays muted. The watchers may see this interplay as choreography, sky and ocean conversing in light and shadow. Would they recall their own seas if they had them? Did their waters shimmer in similar ways, or did they glow differently, perhaps under another star's hue? Did reflection play a role in their first awareness, teaching them to notice patterns, to wonder at surfaces? If so, the glitter of Earth might stir something like memory, something like kinship. Reflections do not endure. Each wave passes, each glint shifts, each sparkle disappears as soon as it appears. Yet together they form a constant presence, a rhythm of impermanence. Would the watchers feel comfort in this? The reminder that beauty need not last to be real, that transience is its own form of permanence, always renewed, always vanishing. The oceans, in their shimmering, offer a kind of mirror not only to the star but to perception itself. They remind that seeing is never passive, it is always participation. To notice the glitter is to join in it, even from afar. The watchers may let the thought linger, that the planet, without meaning to, reflects not only light but wonder. And so they continue drifting, watching the surface scatter brilliance into space, reflections in the ocean light. Not a message, not a code, but a reminder that sometimes the simplest physics feels like conversation. They withdraw a little into distance, not to abandon the blue world, but to fold it into a longer rhythm. Patience becomes their only instrument, and stars are the measure of that patience. The nearby sun burns with a steady calm, a lantern with oil enough for ages yet. Around it the planet continues to turn, a moving bead on a slow abacus of days and seasons. If they wish to know whether minds arise here, or arise again, they must learn to wait as stars wait, without urgency, without fatigue, attentive as stone under rain. Would they mark their vigil by orbits or by the quieter metronome of stellar change? A star's light flickers minutely with cycles, with spots and moods. Its ultraviolet breath swells and recedes, its wind strengthens, then softens. Each oscillation offers a clock. They may tie their interval to these pulses, returning when the star has completed this many turns of a hidden wheel, when its corona hums in a familiar key. To them, a century might be a heartbeat, a million years a paragraph. The difference between now and later compresses into simple questions. Is the air the same shade of blue? The oceans the same shade of dark? The nights the same kind of quiet? If life that speaks has not yet emerged, they may decide to drift outward and let time enlarge. They could leave small watchers behind, silent beads strung along space, each one tasting the light that the planet returns to the dark, each one storing a patient diary of brightness and breath. No beacon announces their presence. Their devices keep vigil the way lichens keep stone, the way old trees keep hillsides, by simply remaining. Would they fear to miss the brief span when voices first break the surface of silence? Perhaps they accept that missing is inevitable. Even on their own world, beginnings may have occurred in places no one watched, in seasons no one recorded. Discovery is always partial. What matters is not to seize a moment, but to be ready when a pattern holds. A single year of radio, a century of fire, a millennium of metal, all can pass like weather. But a sustained alteration in the air, a new choreography in night, a repeating symmetry on land that adapts to river and mountain with unhurried insistence. These endure long enough for patient instruments to notice. The watchers understand the planet's habit of erasure. If minds rise and fall as tides do, swelling, spreading, then withdrawing into silence, the sea of time will flatten their traces. So they wait not for monuments, but for cycles. They ask, does breath change the air in a way that returns? Do lights appear in darkness and then learn to spare themselves, dimming, moving, rearranging with modest restraint? Does the noise of radio swell and then quiet into whispers shaped like thought rather than shout? Patterns can mature. Perhaps intelligence, if it learns, becomes less visible with age. They are prepared for that, too. They consider longer horizons. The star's stability buys the planet another chapter. The moon's pull steadies the tilt. The moving continents keep nutrients circulating, keep soils young. A world with such gifts may offer many trials for awareness to attempt itself, not once, but in several eras, not only on land, but perhaps in coasts and shallows, perhaps in cold, perhaps in heat. If intelligence is a seed, the climates. Many seasons offer soil of differing character. Some seeds fail, others bide their time. The watchers set no deadline. They let the idea of firstness blur. Would they return at intervals too vast for our counting? Perhaps they never leave. Perhaps their attention is a halo that thickens and thins, like a tide moving through the long estuary of centuries. They could graze the system with slow arcs, their path chosen so that the planet and its moon draw them back again and again, like a pair of hands folding cloth and unfolding it. Or they may set their gaze from afar, triangulating with other patient eyes seated in other quiet orbits, weaving a net of observation so loose it never tangles, so wide it never tears. They measure and they imagine. They imagine an age when forests invent new rhythms of breath that no prior epoch rehearsed. They imagine reefs rebuilding after long decline, then arriving at architecture subtly altered, stabilizing shores in patterns that more firmly defy storm and surge. They imagine nights that gleam in geometries that match no glacier, no river, delta, yet drift with practical grace, as if a mind has learned to listen to geography rather than impose upon it. And they imagine the opposite. Long ages where nothing speaks beyond the green and the tide, where patience is rewarded only with more patience, and wonder deepens anyway. Would they ever try to stir the process, to nudge the dice? Their stillness suggests not. Intervention would be an answer. They prefer questions. They attend the planet as a reader attends a poem, by listening, not by rewriting. They trust time to conduct its own experiment. If minds rise, they will rise in the grammar of this world, not in the grammar of visitors. If they do not, the absence remains a presence, an elegant solution to the same equation under different boundary conditions. Both outcomes satisfy curiosity, because curiosity loves what is true more than what is hoped. So they practice a discipline of gentle thresholds. If a signal of intention appears and repeats across seasons, they let it repeat many more times before allowing belief. If lights arrange themselves too sharply, they wait to learn whether rivers or ice might have made the same alignments. If the air tilts toward a new composition, they ask whether volcanoes have joined the choir. Every test delays conclusion, but every delay is kindness to truth. Patience keeps error at bay, and error always arrives in a hurry. They think of stars as teachers. Stars do not hurry toward their endings. They spend most of their lives in quiet labor, fusing light from the simplest elements, providing a steady envelope of time within which planets can practice complexity. To learn from a star is to let the long interval do its work. Suddenness has its place, in lightning, in births, in extinctions, but endurance shapes what follows. The watchers sovereignly align themselves with endurance. If intelligence blooms here and chooses to gaze outward, what will it find? Perhaps only the record of being watched, not a message but an absence of interference, as though the cosmos has left a chair empty beside the fire. The watchers keep that chair ready. They avoid declaring themselves, because any contact they could initiate might decide a story whose value lies in being undecided. They allow Earth to remain a question to itself first, and if intelligence bloomed once and fell, could it bloom again? They find comfort in cycles. Forest after fire, reefs after bleaching, soil after flood. The world repeats recovery in altered keys. Minds, too, might reprise, changing instruments, choosing softer tempos, finding quieter ways to endure. If so, the watchers will be here when the motif returns, not because they must, but because patience is their way of seeing. Night unthreads over ocean, and the planet's curve carries day forward. The star keeps its pale promise. The watchers nestle into that promise and extend it with their own calm. No schedule, no expectation, only readiness. The blue world turns within that readiness like a bead on a string of centuries. Whether or not voices rise again, whether or not lights learn to spell careful patterns in the dark, the waiting itself becomes a kind of listening, a long, steady breath shared between star and observer. They grow attentive to what does not last. Evidence, like dew, forms and disappears, leaving only a darker patch where it rested. The watchers have seen worlds write and erase themselves, but here the erasures feel especially deft. Earth keeps records lavishly and loses them lavishly, too. Every page that survives does so by favor, not by right. Rain begins the forgetting. It falls, gathers, runs downhill, taking with it the soft and the soluble. What holds together in drought crumbles in flood. Wind continues the work, lifting grains, polishing edges, scouring inscriptions no hand carved, and all the more easily any that were. Heat expands, cold contracts, cracks widen. Frost pries at seams until stones confess their interiors to the weather. Roots enter, curious and tireless, splitting rock with patient insistence, while fungi and bacteria dissolve what root and water cannot. Scavengers strip what falls. Insects, teeth, acids, sunlight. Each has a turn. Nothing, or nearly nothing, resists the chorus for long. Even bones ally with the wind. If they are not quickly buried, they flake and vanish. Even burial is no guarantee. Groundwater changes tastes through the seasons, dissolving, reprecipitating, trading one mineral for another until the original form is gone and only an impression remains. To become fossil is to be chosen by circumstance. Rapid cover, low oxygen, the right chemistry, the mercy of being left undisturbed. Most lives miss the invitation. The record that results is not a census but a myth surviving on scraps, suggestive, and partial, grand in outline, spare in detail. They consider artifacts, a word that presumes intention and endurance simultaneously. Wood rots, then feeds the soil. Fiber unwinds to dust. Leather and leaf return to dark. Even stone tools, if left to weather, become flakes among other flakes, their angles softened, their stories plausible but not certain. Metals oxidize back toward ore, then slip into groundwater and travel. Iron returns to rufous stains, copper greens and then disperses. Gold lingers but migrates, reassembled by rivers into new seams. Glass devitrifies, grows cloudy, crazes, fractures, returns to sand. Ceramics can endure, but they shatter, and their fragments scatter. Plastics persist in ways that disguise themselves. Not monuments, but moats, not inscriptions, but dust that resembles pollen under a generous lens. The very materials that might seem durable choose fineness over form, becoming everywhere and unnameable. Built space fares no better. A city of timber, reed, and clay dissolves into soil, leaving only a faint change in color, a slightly richer loam, a platform of compacted earth soft enough to be mistaken for a terrace of wind. Even stone cities depend on mortar, and mortar depends on chemistry that invites water far too readily. Roofs collapse, walls surrender, vines take hold where rain cannot reach, rooms fill, floors rise on their own debris until the place is level. Again with the surrounding plain. The forest does not remember where the street ended. The desert buries what it cannot abrade. Shorelines forget with the tide. Time does not only sand the surface, it folds it. Continents collide and lift their scars into mountains. Mountains weather into sheets of gravel that rivers carry to basins where pressure makes rock again. The oldest floors of oceans slide down into the mantle along cold lips of crust, their sediments scraped off and reworked, their cores returned, to heat where crystal lattices melt and their stories stop. A plate's lifetime is long to a creature and short to a planet. Even the most stubborn inscription, if written on moving crust, will not outlast the patient appetite of subduction. Ice is a careful librarian and a ruthless editor. It stores air in bubbles, dust in layers, acidity in thin lines of memory, but it releases all it holds when climate has asked enough. Glaciers advance and plane off hills as if correcting a draft. They retreat and leave behind only pebbled grammar that says ice was here without specifying what it took. Peat preserves, but only where it forbids oxygen. Bog bodies endure as exceptions and warnings. Preservation is provisional, contingent, local. Caves keep what other places lose, yet caves flood and collapse. Crystals grow over paint. Stalagmites rewrite rainfall. A single tremor closes the room forever and thus protects it, or seals it after it has already been emptied by another hand. Even the instruments that minds might favor, magnetic tapes within stones, charges in the slight defects of crystals, alignment of iron grains that record where north once stood, all receive and all are reset. Poles wander, fields reverse. Temperatures pass a threshold and alignments relax. Cosmic rays change isotopes with slow insistence. Decay ticks its arithmetic through every archive simultaneously. To think of permanence is to forget the arithmetic. To remember it is to accept that long enough is the only kind of forever the planet offers. What of signals in orbit? Orbits decay unless the air is perfectly absent, and even then gravity keeps a long to-do list. Tides tug, resonances accumulate. Collisions seed more collisions until fragments become glitter that drifts downward as transient meteors. High paths endure longer, but the system is not infinite in its patience. A world keeps its sky tidy in the scale that matters to it, which is the time of seasons and plates, not of decades or dynasties. They think of biases, of how much easier it is to preserve hard things than soft, abundance than scarcity, catastrophe than quiet. A single ash layer betrays a violent year with exact grace. 10,000 calm years leave less. The watchers understand that quiet cultures, if such a phrase makes sense, might pass without fossil. Societies that prefer fiber to metal, that prefer settlement that moves with season, that choose to leave a place unchanged rather than mastered. These could live for ages here and vanish as cleanly as a migrating shadow. Even loud cultures, if brief, might be folded into the noise of fire and flood. They imagine knowledge that does not anchor itself in matter. Stories carried only in minds, songs that bind groups and guide harvests, mathematics held as practice. Rather than script, maps recited, medicine taught by demonstration, law as memory braided into kinship. Such knowledge can pass itself along for centuries, and then fail within a handful of winters, undone by hunger, dispersal, or the small accident of a generation that cannot stay. Fragility of evidence does not mean fragility of meaning. It only means meaning is mortal in form. They let the thought widen to include their own remembering. Perhaps they too lost libraries to time, archives dissolved by heat, data eaten by bit rot, inscriptions eroded by the very solvents they used to clean them. Perhaps they learned that redundancy across media is a kind of ecology, that information survives best when it lives in many habitats at once, stone and bone and tree and mind and pulse in the sky. Earth seems to prefer a similar ecology. Memory in ice, memory in rings, memory in shells, memory in dunes. Yet each habitat has a predator. Each can be starved. The fragility does not dishearten them. It clarifies. It teaches that what remains is weighted toward accidents of preservation, not toward the fullness of what was. It invites humility, to read lightly, to treat any conclusion as a sketch that could be redrawn when another layer is found or when a known layer is reinterpreted in a new light. The planet is not uncooperative. It is busy, writing, erasing, rewriting, not for us, not for them, but because that is what heat and gravity and chemistry do when handed 4.5 billion years and a little water. They imagine a handprint, on mud against a riverbank, dried, then lifted by a flood and folded into silt, then pressed into shale and heated until the print becomes only a wave in mineral. The gesture turned back into geology. They imagine a lattice of streets that remains in plan long after the walls have fallen, then becomes field boundaries, then woodland edges, then a shadow in soil that a future root will unknowingly redraw. They imagine pages becoming smoke, smoke becoming carbon in a leaf, the leaf becoming peat, peat becoming coal, coal becoming heat, heat becoming wind, wind carving letters no eye will ever learn. Evidence does not die. It changes address until the mail no longer follows. The watchers accept that entire histories can vanish and still have been real. They do not use disappearance as verdict. Instead, they take disappearance as a property of living planets, as ordinary as rain. In the light of that acceptance, the question they carry grows softer rather than smaller. Could there have been others? The answer remains what it has always been. Perhaps. The fragility of evidence keeps perhaps alive. Evening. Slides across the oceans, and the world's surfaces darken to a uniform calm that hides their restless editing. Somewhere, a cliff drops a little into the sea. Somewhere, a dune advances by the width of a grain. Somewhere, an archive deep under ice loses a year to melt and keeps another year intact. The planet continues its work of remembering and forgetting. The watchers, attentive and untroubled, let the work continue, grateful for what the world is willing to keep, gentle with what it lets go. They begin to imagine not merely watching, but being, a gentle rehearsal that asks nothing of the world. It borrows. In their quiet simulation, they do not land. They lean inward. They allow a thought to wear a body made from local rules. gravity, a steady hand on every motion, air, a patient choir of nitrogen, oxygen, argon. Their imagined lungs, if lungs are the right word, learn to sip this blend. If their chemistries differ too far, they picture membranes and catalysts to translate between worlds, a thin diplomacy at the boundary of breath. The rehearsal remains kind. It leaves no footprint. They choose a morning near the sea. The star stands at an angle that turns water to silver and stone to slow embers. Tides climb and fall under the moon's remote guidance, pulling edges of ocean like a careful seamstress tightening a hem. They picture standing at that edge, limbs adjusting to 1G of insistence. If they come from weaker pull, their imagined muscles sing with surprise. If from stronger, they feel lightened, almost careless. None of this requires arrival. It is the empathy of physics, a willingness to feel what forces here would feel like. The day is 24 hours long. Give or take a few heartbeats of the planet's tiny irregularities. They let circadian rhythm unfold within them. Wakefulness braided to light, a drift toward rest as darkness returns. If their home turned slower or faster, the cadence here asks for new habits. They oblige. The tilt of the planet draws season, across land and sea. They find themselves hungry for winter's low sun, for summer's long evening, for equinox when balance seems a promise rather than an average. Weather gives them new clothing each day, cool on the shadowed side of dunes, warmth against a south-facing rock, the kiss of salt. They try on senses as this world emphasizes them. Light arrives in a spectrum shaped by a G-type star and filtered by atmosphere. Blue scatters, red reaches, green steadies the center. They imagine eyes tuned to this range, or different organs that translate photons into feeling. They imagine the polarization of sky as a faint geometry, a compass in air. They borrow magnetoreception from birds and turtles, letting the planet's field brush the mind like a gentle hand that points without insisting. They borrow the hairs of insects to taste wind, the lateral lines of fish to hear pressure speak. They lend themselves echolocation under cliffs, the sonar of a broad bay at night, the electric murmur of a ray hidden in sand. In this rehearsal, they become many without ceasing to be one. Not to claim, but to understand how a place tells itself to those who live within it. Biochemistry flickers in their thought. If life here builds on carbon in water, using enzymes that lean left in their handedness, they imagine how their own machinery would fare, what sugars to taste, what toxins to respect, what proteins to fail at copying. The imagined palate tests resin and leaf, salt and mineral, and learns humility quickly. They realize that to survive is not the same as to belong. Belonging takes generations of conversation between body and place. Their dream bows to that duration and stays content with a quiet visit. They wander inland without moving. Forest understory gathers shade into rooms. Ferns articulate air into fronds of coolness. Insects weave a frequency that stitches space together. Birds write trajectories that tie branch to branch. They let themselves stand in 1 square meter and discover it is not small. It is as large as attention allows. Soil breathes. A mycelial. Web signals and shares. A stone sweats the memory of last night's dew. Gravity is not only weight downward, it is also the reason a drop becomes a bead, the reason a leaf drips when it does, the reason a trunk rises straight enough to risk the wind. They imagine swimming without entering water. The body they borrow rearranges itself for buoyancy, for viscosity, for the way light fractures into coins a few meters down. Salt carries them differently than fresh. Temperature layers the sea into floors of density. Sound travels with a clarity unknown on land, so that distance becomes intimate. They learn, in their imagining, how tide pools become cities at low tide and complicated sky at high, how kelp forests are cathedrals that rebuild their aisles after every storm. They feel the moon with their skin, not romantically but literally, a slight loosening in joints as the tide turns. Ethics remains in the foreground of their dream. They do not take, they do not announce, they do not correct. To project themselves into a world is to practice restraint. They want to know whether they could live here without flourishing at the world's expense. The rehearsal tests customs against constraints, how to shelter by borrowing what wind already shapes, how to travel by following paths water has already chosen, how to harvest only the interest a system offers without touching its principle. Whether such living is possible depends on the answers of soil and season more than on hope. The simulation does not flatter them. It gives honest limits. They accept the limits the way a tree accepts shade, as boundary and as guidance. They test nights. The sky clears. Stars arrive in impossible numbers where the atmosphere and weather allow. In other places, clouds hide them and make a room of Earth's own ceiling. Auroras comb green fire through polar dark. Meteors tick as brief lines. The Milky Way rises like a river of salt. If their eyes see farther into infrared or ultraviolet, the tapestry changes. Gases outline themselves. Heat writes animals onto the field. They imagine the sound of nocturnal life, that precise local symphony tuned to temperature and time of year. They imagine becoming quiet enough to be mistaken for part of it. They ask what work would look like. Not labor measured in output, but repeated acts that knit a life to a place. Gathering, mending, listening, tending, verbs that other beings already use. They picture guiding floodwater into channels that trees approve of, weaving reeds into shelters that wind nods to, burning lightly in seasons when fire is a medicinal cut rather than a wound, naming nothing, obeying many names. Could strangers ever do this? The rehearsal suggests a gentler truth. If they were to belong, they would cease being strangers long before anyone called them residents. Belonging is not an outcome. It is a method. They consider illness. New worlds expose new vulnerabilities. Microbes do not intend harm, they only complete their cycles. The imagined body learns to be cautious with contact, to keep membranes intact, to let curiosity stop at the threshold of water taken into blood. They trace the immune arithmetic and decide again on non-interference. Some visits are possible, only as thought experiments, as dreams that do not touch what they love. They practice listening to time. Stones speak with the accent of centuries. Dunes speak weather. Ice speaks slow breath. Rivers speak compromise. Reefs speak patience mixed with panic. Forests speak in 10-year sentences and also in centuries-long paragraphs. They let these voices overlap without translating them into a single language. A place is many clocks at once. To live here, even as a thought, is to accept polyrhythm.
In a last scene quiet as the first, they return ashore. The planet's bright knife of reflection lengthens and slides. In their rehearsal, they leave no footprints on wet sand. Yet they feel the coolness that would have risen through imagined souls. The moon's pale road lies on water. The road moves as they do not. They understand that their best presence here, for now, is absence that includes attention. In that absence, they are not empty. They are full of detail, of gratitude, of relief that such a place exists whether or not anyone lives within it as they might. They withdraw from the borrowing without closing the door. The dream remains available, not as entitlement, but as gratitude. Earth keeps turning, unmodified by their curiosity, unharmed by their rehearsal, unburdened by their wish. The watchers return to watching, carrying within them the tenderness that comes when imagination meets a real world and chooses reverence over claim. The watchers drift outward again, far enough to let the planet settle back into wholeness. From this distance, no forest is separate from desert, no reef from river, no mountain from plain. All curves merge into one curve, a sphere lit on one side and shadowed on the other. To see the world like this is to sense it as a single organism, not literally perhaps, but figuratively, as if every system, every cycle, were a limb of something larger. Would they think of it as alive? Not in the way a creature breathes, but in the way balance persists through change. Oceans circulate heat. Forests circulate carbon. Winds distribute dust. Rivers deliver minerals. Volcanoes recycle stone. Each system answers to another, no part entirely alone. The watchers may recall the word they once used, homeostasis or something like it, a term that means balance by feedback, steadiness by adjustment. To call a planet alive is metaphor, yet metaphor may be the truest way to feel its coherence. They notice how fragility and resilience weave together. A single eruption can darken the skies, yet life recovers. An asteroid strike can erase whole kingdoms, yet niches refill. Ice can grip continents, yet warmth returns. This resilience may look like design, but it may be only the mathematics of diversity, the probability that somewhere something will endure. Still, from afar, it has the flavor of intention, a world that insists on continuing, no matter the interruption. Would they ask whether intelligence is part of this balance, or a disruption of it? Perhaps both. Minds that build can destabilize, but they can also repair, restore, invent harmonies where none existed. The watchers may wonder whether Earth is on the cusp of such a transition now, whether intelligence, if present, is still learning how to belong within the planetary organism. They do not rush to judgment. They know that belonging takes time. The unity of Earth is most visible at night. Darkness gathers, and from afar, the sphere softens into shadow. Yet even in shadow, continuity shines. The faint glow of auroras, the reflected light of the moon, the scattering of starlight across clouds. The boundary between land and sea disappears, but the whole remains. Day and night are not opposites. They are phases of one turning. Would they compare this unity to their own origins? Perhaps they too once saw their world whole for the first time, realizing that divisions are illusions, that continents and cultures are part of one body. Or perhaps their world never offered such clarity, and Earth feels uniquely singular to them. In either case, the sight inspires humility. To look at a planet as one is to feel the smallness of oneself. The watchers linger on this thought, that wholeness is not perfection. Storms still rage, continents still fracture, species still vanish. Wholeness means only that everything participates in everything else. Even ruin belongs to the organism. Even silence contributes. Even absence is part of presence. They do not need certainty to find meaning. They let the image of Earth, round, turning, luminous in its balance, rest in their perception like a held breath. They accept that to witness wholeness is itself a kind of contact, even if no words are exchanged. And so they remain silent above a planet that is more than the sum of its parts, a single breathing system turning slowly through the dark. The watchers extend their senses beyond the sphere, into the quiet geometry of its companions. Earth is not alone. A smaller body circles it faithfully, the moon pale and scarred, tethered by gravity's invisible cord. From afar, the two seem a duet, one alive with water and air, the other silent, cratered, still. Yet even silence has meaning. Would they linger on the contrast? Earth is restless, green, cloud-wrapped, reflective. The moon is bare, gray, echoing with the memory of impacts. Where one recycles its crust, the other preserves its scars. Where one is shrouded, the other exposes itself without veil. Together they are a pair, opposites bound in orbit, a dialogue between vitality and austerity. The watchers may sense how the moon steadies the larger world. Its pull anchors Earth's tilt, preventing wild swings that could make climate unpredictable. Its tides stir the oceans, mixing nutrients, guiding the rhythm of shores. Would they see this as accident or as gift? Would they wonder whether life depends not only on a planet, but on its companions, subtle influences that shape possibility without ever intending to? They may think of their own worlds. Did they have moons large enough to matter, small enough to endure without tearing themselves apart? Did those companions stabilize or destabilize? Perhaps their own past taught them that balance often requires more than one body. Alone, a world wobbles. With a partner, it learns steadiness. The moon itself, though silent, tells a story. Its surface holds craters billions of years old, preserved because no wind, no rain, no plate tectonics erased them. It is an archive of impacts that Earth has long forgotten. To study the moon is to glimpse Earth's early life, the bombardment, the collisions, the chaos of beginnings. Would the watchers appreciate that such memory survives not on Earth, but beside it? That sometimes a companion remembers what the self cannot? They may also notice the rhythm of eclipse. From their vantage, the moon sometimes slides across the face of the sun, shadowing Earth, darkening day into twilight. At other times, Earth's shadow washes over the moon, painting it red. These alignments, predictable and beautiful, are not messages, but they feel like choreography. Would the watchers sense wonder in this dance, or only mechanics? Perhaps both. For mechanics, when seen from afar, often resembles art. The pair continues their orbit around the star, together yet distinct. Earth turns with oceans and forests, the moon with dust and silence. Each needs the other, though neither speaks. To the watchers, this companionship may suggest something profound, that wholeness is not isolation, but relationship. A world may be complete in itself, yet more stable, more beautiful, when joined to another. And so they observe not only Earth, but Earth and Moon, a pair that together create tides, cycles, shadows, and memories. A pair that reminds them that no world truly moves alone. The watcher is patient in their orbit. Notice how the planet seems poised between eras. It is not the frozen silence of its earliest days, nor the molten chaos of its birth. It is not yet the distant future, when its star will swell and oceans may boil away. Earth rests in a middle age, balanced between too young and too old, between barrenness and decline. Would they sense this as a transition rather than a condition? Perhaps. The signs are subtle but present. Continents drift apart, but slowly, promising new collisions in ages to come. Ice lingers at the poles, but waxes and wanes with the tilt of orbit, hinting at shifts that will alter coastlines. Species flourish, yet extinctions continue in steady rhythm, some abrupt, some gentle, as if reminding life that nothing lasts unchanged. This moment from their vantage is both fragile and fertile. A climate stable enough to support complexity, yet restless enough to challenge it. Oceans circulating warmth, forests balancing air, rivers feeding plains. To them it may look like a crossroads, a planet still open to possibility, not yet fixed in its final trajectory. Would they wonder if intelligence, if it exists here, is also in transition? Perhaps young, still learning how to live within limits. Perhaps experimenting with tools, fire, language. Perhaps just beginning to sense the larger system that holds it. Or perhaps already past an early peak, now facing whether it can endure. Without certainty, the watchers only speculate. To them, every civilization is a threshold, every threshold a question. They may reflect on their own middle eras, if they had them. Times when balance was precarious, when choices mattered, when small shifts decided whether their world moved toward collapse or renewal. Perhaps they remember watching their own atmosphere change, their own forests vanish or return, their own oceans rise and fall. If so, Earth's transitional state may feel familiar, a mirror of struggles once faced. The watchers might notice that transition is not a moment, but an extended state. A planet is always between what it was and what it will become. Earth is not fixed in now. It is always becoming. To see it is to see motion stretched across deep time. Would they envy this, or would they fear it? Stability offers safety, but change offers growth. A planet in transition is a planet alive with potential, but also with risk. To visit Earth at this moment, or to discover it first, is to encounter not finality, but uncertainty. The watchers do not resolve a question. They let Earth remain as it is, a world between eras, luminous in its uncertainty, beautiful precisely because it is not finished. Distance becomes their teacher. It does not scold or flatter. It simply places everything at arm's length until the shape of meaning can find itself. The watchers have crossed longer gulfs than this. But here the distance feels particular, not just a number between stars. It is a kindness that protects what is being seen from the hands that would otherwise reach. It slows conclusion, thins certainty, and invites a different kind of attention, one that listens more than it speaks. Would they be the same without distance? Probably not. Nearness tempts intervention. Distance teaches restraint. Nearness magnifies detail. Distance restores contour. Here, because they cannot touch, they discover how much can be known by patience alone. They learn to read a world by its breath, its light, its shadow, its repeatable hesitations. They learn that not touching is not ignorance. It is another kind of knowing, a knowledge that leaves the known intact. They measure parallax and feel philosophy in the geometry. A small shift in their vantage, a tiny baseline between two positions, and the planet's place in space resolves with confidence. From this they infer a principle they already suspect. Perspective is not an error, but a method. To move slightly and compare is to learn honestly. They let the idea breathe, that truth is not a single still image, but a weave of angles gathered slowly, then held without tightening the knots too much. Light brings time with it. What reaches them is already past, however slightly. The planet they watch is never quite the planet that exists now. The realization does not disturb them. It comforts. Everything is always a little earlier than itself. Even their own reflections arrive late by the span of thought passing through memory. They consider whether all discovery is time travel in small steps. To notice is to receive a past. To act is to change a future. To wait is to let both remain a little more themselves. They test models against the quiet Earth offers. Before, they may have carried assumptions sharpened by long silences between stars. That if minds exist, they must shout. That if oceans exist, they must breed thunderous ambition. That if balance exists, it must be proof of guardians. The blue world softens these assumptions. No shouting rises from it, yet it sees glitter with persistence. Its forests breathe with coherence. They adjust their priors gently. Absence of proclamation becomes only that absence of proclamation, not a verdict on minds, not a conclusion about fate. Would they rename themselves because of what they see? Not in letters, perhaps, but in posture. They become a little more students. They become a little more neighbors. Discovery of another world first, before any world has discovered them, empties them of a certain grandness and replaces it with companionship. The word alone loosens its grip. The word together acquires a wider radius. Their ethics ripen in the space between curiosity and care. Non-interference is not indifference. It is a form of respect. Distance makes this easier to practice. Without the leverage of closeness, they cannot press upon the planet, and so they do not try. Responsibility, in this philosophy, measures itself not by the size of the act, but by the tenderness of its effect. The kindest action may be no action at all. The truest witness may be the one that leaves nothing altered but the witness. They examine naming. To name is to gather. To gather is to risk enclosing. Names are useful, but they can behave like nets that tighten until the caught thing cannot move. They hold their names lightly, including the one a nearby culture once used, Earth, if they have learned it by any means, or its equivalents in their own lexicons. They let the world remain mostly itself, a moving identity larger than their syllables. Perhaps they keep a private moniker that is not a label, but a vow, the blue that is not ours. Distance rearranges their scales. The span between two storms becomes a phrase of weather. The span between two ice ages becomes a paragraph of climate. The span between two supercontinents becomes a chapter of planet. Their own lives fit differently inside these measures. If they once timed themselves by cities or inventions, they now time themselves by the stars' small cycles or the longer pulses of fields and rocks. The change does not diminish them. It frees them from urgency that did not belong to them. It stretches patience from practice into temperament. They refine their instruments, but they refine themselves more. Precision increases, yes, spectre cleaner, angles steadier, diaries of brightness less noisy. Yet, the larger calibration is inward. They become less certain that they ought to understand everything. They become more willing to carry questions like smooth stones in a pocket, turning them in thought without wearing them away. It is a discipline to ask without insisting, to imagine without claiming. Distance makes this discipline feel natural rather than forced. They wonder what distance does to love, not the love of possession, but the quiet affection for a thing that does not need you. It is a love without argument, relieved of the task of being returned. Can one love a planet that has not asked for love? They decide that love here is the feeling that keeps interference at bay. To care is to refrain. To refrain is to allow. They let that be enough. They also notice how discovery folds back upon self-perception. If oceans and forests and magnetospheres are not rare, then their old sense of exception softens. If they are rare, humility deepens for a different reason. The rarity calls for gentleness. In either case, identity shifts away from dominion toward stewardship of attention. They are not the measure of the cosmos. They are one of its listening posts. That is not lesser. It is clearer. Distance clarifies paradox. To be far is to see the whole. To see the whole is to lose the particulars that make the whole. They accept that no vantage is complete. The philosophy that emerges is not either slash or but both slash and both intimate and detached, both analytical and awed, both patient and alert. They keep a place inside themselves where wonder and method sit together without argument. They consider selection itself. Perhaps they found this world first because their instruments favor water signature, or because patience finds easiest purchase on tempered stars. Perhaps they did not find it first at all, only first to their noticing. The thought prunes pride into gratitude. Luck joins skill in the story. Chance becomes a colleague. They imagine how this discovery will echo in their own long memory. Songs may adopt new metaphors. Mathematics may acquire a variable named for the reflectance of oceans. Philosophies may include a clause about the dignity of distance. Apprentices will be taught to hold uncertainty like a cup filled to the brim, carried carefully, not spilled in haste, not left so long that thirst is forgotten. The blue world becomes a teacher without ever intending to teach. Would they change their route because of it? Perhaps only subtly. They will still follow their slow arcs among stars, but with an added softness to their navigations, an added caution to their curiosity, willingness to leave quiet places quiet. They may still build, still explore, still reach. But reaching now includes the gesture of drawing back. At last they settle into a steady orbit of thought. Distance remains. Identity adjusts. The watchers are still watchers, yet they are different watchers. Ones whose idea of themselves now includes the possibility that the best gift they can offer a beautiful world is the preservation of its unawareness of them. This is not erasure. It is a kind of reverence. And the planet continues to turn, indifferent and complete. The philosophy that distance writes upon them is simple, almost austere. Let what is be. Listen longer. Do not mistake the quiet for emptiness or the loud for meaning. If contact is ever kind, it will come from within this patience, not from weariness with it. Until then, they hold their place in the dark, shaped by what they have seen and by the way they have chosen to see it. The watchers have traveled far enough through thought that time itself begins to feel like a landscape. They no longer see Earth only as a sphere turning in space, but as a story unfurling in layers, each one deeper than the last. Deep time stretches beneath them like an ocean without shore, each wave an epic, each swell a million years. To look at the planet is to look through its ages at once. Would they feel overwhelmed by such immensity or calmed by it? Perhaps both. Immensity humbles, reminding any observer of smallness. But immensity also steadies, because in a sea so vast, no single moment decides everything. Change is real, but it is also absorbed, blended into the wider rhythm. To think in deep time is to loosen fear without denying fragility. They sense how Earth remembers, not in lines, but in cycles. Continents merge, then drift apart. Oceans open, then close. Climates warm, then freeze. Forests spread, then retreat. Species flourish, then vanish. Over and over. Recurrence shapes the record. Would they conclude that even intelligence, if it appears, might be part of this pattern? An episode that could rise, fall, and perhaps rise again in another form, another age? To contemplate such cycles is not despair. It is recognition that endings are rarely final. Each extinction clears space for renewal. Each collapse leaves nutrients, niches, opportunities. Life here has been many things: single-celled mats, trilobite swarms, reptile empires, forests of ferns, coral labyrinths. None remain. Yet all have given way to something new. Deep time teaches that nothing is wasted. It is only transformed. Would the watchers see themselves in this? Perhaps they remember their own past extinctions, the fragility of their beginnings, the precariousness of survival. Perhaps they know that endurance often means accepting transformation, allowing identity to shift with circumstance. In this, Earth becomes a mirror not only of what is, but of what is possible. They may notice how deep time erases detail. A century matters little. A millennium only slightly more. Civilizations, if they come, are brief sparks. Even mountains are temporary, wearing down in millions of years. Only the largest gestures, the drifting of continents, the rise of oxygen, the long persistence of oceans, endure. Would they then ask what matters most, the sparks or the gestures? Or would they see both as part of the same continuum, each meaningful in its scale? Deep time also dissolves certainty. The further back one looks, the less precise the record becomes. Fossils thin, isotopes blur, craters soften, sediments are lost. What remains is suggestion, not proof. To study deep time is to live with incomplete knowledge, to accept that clarity fades the farther one peers. The watchers may find this humbling, but also freeing. To not know is not failure, it is honesty. Perhaps they would reflect on how intelligence fits within the scale. Our presence, if noticed, would be fleeting compared to the planet's rhythms. Yet fleeting does not mean empty. Even a short-lived era can leave resonance, as trilobites did, as ammonites did, as ferns did. Intelligence, too, may be another verse in the planet's song, brief but distinct. Would they wait to see how long this verse lasts? They might. Their patience aligns with deep time. To them, decades are moments, centuries only brief pauses. They can afford to listen not for noise, but for continuity. They will know if this spark endures, or if it fades into silence like so many before. For now, they let the immensity hold them. They do not rush to conclusion. They simply allow Earth to be what it is, a planet alive in deep time, a story still writing itself, a question with no need for immediate answer. The watchers remain, their vigil lengthened into something beyond measurement. The planet below turns slowly, but time has ceased to feel linear. It has become circular, tidal, a rhythm that returns endlessly. They find themselves listening not for events, but for recurrence, not for signals, but for echoes. Would they wonder whether discovery itself has changed them more than the world they watch? Perhaps. For in gazing so long at Earth, they have learned patience, humility, reverence. They began as seekers, curious about whether life or intelligence lived here. But curiosity is widened into something quieter, companionship. To witness a world is to enter into relation with it, even without touch, even without reply. They notice how wonder persists even when certainty does not arrive. Oceans still glitter, forests still breathe, clouds still shift. Each turn of the planet offers new configurations of the same elements, always familiar, never repeated. To them, this endless recombination is not monotony, but meditation. A world does not need to change to remain mysterious. It needs only to continue. Would they ask themselves why they stay? They have the capacity to travel elsewhere, to seek other stars, other worlds. Yet they remain, orbiting patiently, watching this one. Perhaps because discovery is not about finding many things, but about finding one thing deeply. Earth invites depth. To know it even partially is to know something of the cosmos itself, how matter can assemble into forests, oceans, storms, and silence. They may imagine what it will be to return here after long absence, to come back after a million years and see whether the forests are still green, whether the glaciers still gleam, whether new forms have arisen to walk or swim or fly. They know the planet will be different, But they also know it will still be Earth, still itself, still turning beneath its star. The watchers hold no urgency. They are not keepers of verdicts. They are companions to mystery. To discover Earth first is not to solve it, but to let it remain unsolved, luminous in its ambiguity, alive in its silence. And so they continue, orbit steady, perception soft, thought patient. Earth turns below, endless in its becoming. The watchers remain in their long stillness. The blue world continues beneath them, turning without hurry, cradled by its star, companioned by its moon. Nothing needs to be concluded. The oceans do not declare themselves. The forests do not announce their purpose. The silence of the air is not emptiness, but rest. To gaze this long is to feel time soften, to let boundaries dissolve, past and present fold together, and the future lingers only as possibility. Earth does not ask to be solved. It only asks to be noticed, to be allowed its turning, its breathing, its patient drift through the dark. Clouds gather and scatter. Night slides over oceans like ink poured across glass. The moon pulls the tides in its rhythm. Stars keep their quiet watch. Everything continues exactly as it must. And the watchers distant, gentle, unintrusive. Let it be. They drift with calm attention, content not to know all, content not to interfere. For sometimes the greatest gift is to accept a world as it is, whole and unfinished, mysterious and complete. The earth turns, and still they wait. The earth turns, and still they listen. Silence deepens, steady, luminous, unbroken. End of script. Sleep well.